Okay, we're gonna begin. This is editing the marked vectors homework for worksheet. I'm going to update this and send you later. Please remind me. I'm
Okay.
saying this for the recording. So question 2, ABCD is a square. So what do? We draw a square first, but make sure that it's in alphabetical order. Okay, don't need to be too neat. Then M and N are midpoints of B, C, and CD. You got AM equals to P, so we're gonna draw that. By the way, your notation, I keep on seeing V without the tilde below when you're referring to a vector. P don't have a tilde below. Q don't have a vector below. Very bad. Please make sure you got a tilde
Okay.
to indicate a vector.
Okay.
You see in the question paper, they use a bolded letter to represent vectors. Here in real life, we get a paper handwriting, we cannot use bolded. So of course, we are going to do an alternative, which is the tilde. It's to distinguish between a vector and a scalar. Okay, anyways, that was just a side note on the notation. And also here, there's a vector Q, AN, vector AN. All right, so what you want to do, you want to find vector AB. What's our goal, our objective? Find vector AB, find vector AC, find vector BD in terms of P and Q. So it's good to write out the goal, so you can answer the question. There were a few times when you did a lot of working, you found your lambda and whatever, then you forgot to answer the question. It's like a social studies skill. Like you must answer the question. Okay.
Okay.
All right. Yeah. Don't just do the working and never answer the question. Okay, moving on. So let's see what we can do now is we want to find out, let's say vector, I don't know, AB first. So in this case, right, what do you notice about vector AB? It is actually just how do you put it? It's really just vector A to M, then from vector M to B. In other words, vector AB is just AM plus MB. Vector. But what is AM? Vector P. But what's MB? This one may be a bit confusing. What is MB? Don't know. Leave it. Leave it first. Then let's see. How else can I continue this? Let me see. Okay, I'm gonna translate this into vector AD. So instead of vector MB, I'm gonna say that it's really just half of vector DA. Do you agree? This is MB, this is DA.
Yeah.
So I times half because it's a midpoint. 1-to-1 ratio. 1-to-1 ratio. Then what else can I do now? Since I know it's DA. Can't really do much, so I'll leave it alone. Next, this equation 1. Then after that, you have a vector Q, right? Vector Q in this case. What would I want to do? Let me think a little bit. Okay, got it. So let's just try to find our vector P as the subject. Okay, this one, move away. Vector P. I am following the solution key now. I'll call this as equation 1. Do you agree so far?
Yeah.
Can then let's try to find out an expression for vector Q now. Vector Q over here is vector AN. Do you agree that it's just vector AD plus vector DN?
Yeah.
Can okay, good. So what is vector AD then? Vector AD is actually just negative of vector DA. Correct? Yes?
Yeah.
So the order, Then dn is half of AB.
Yeah.
Can I check that the direction is the same and the magnitude is the same? dn over here, AB over here. Then you half it. Same direction, but halved. So same magnitude as well. Okay, so it's equal. Can? Good.
Can.
This is equation 2. Let me just make it neater. I'll write down vector Q again. Then now you need to do simultaneous equations. Okay, this one is little bit crazy. Okay, let's say I take 1, I times 2. Okay, what do I notice? I will get 2p equals to 2ab minus half times 2 is 1, so vector dA. I'll call this equation 3. Can?
Can.
Then I'll take the equation 2, I times 2. What will I get? Maybe I should draw a line. What will I get? I will get 2q equals to minus 2dA plus half times 2 is 1, so vector AB. This is equation 4. Okay, what can I do now? What can I do now?
Sub in.
Sub in. Okay, sub what into what?
The 3 into 4.
3 into 4. Yeah, you can do that. Okay, let's just make modify the 4 a bit. Let's make AB the subject. Okay, so AB here, it will be 2q plus 2dA. Right? Then 4 sub into 3. I think that will be easier when you have a single thing as a subject. You can just sub directly in. So that's what we're going to do. Sub 4 into 3. Sure. Then in that case, we'll get 2p equals to 2ab. Sorry, the AB gets replaced, right? You're substituting. 2 times of AB in this case from equation 4 is 2q plus 2dA. And then you minus dA. That doesn't. Something is funny. I'm just gonna multiply out first. 4dA minus dA, and then they cancel off, become 3dA. Still not complete. Right? We're trying to solve for what? We're trying to solve for AB, AC, and BD. Oh, but wait, we managed to make dA in terms of Q and P already. Correct?
Yeah.
So we are almost on the right track. Almost. Yes? Yes?
Yeah.
Okay, good. Then we can now, we want everything in terms of vector P and Q, right? Remember the goal is AB, AC, and BD. We have AB over here. So we just need to eventually find out what is dA and sub in terms of P and Q. We also need to later find out what's AC and find out what's BD. That one we can do later. Okay, so first we make dA the subject. Let me zoom out a little bit. Here I got 3dA is equal to 2p minus 4q. Then divide by 3. So you get 2/3 p minus 4/3 q. That's vector dA. Let me just move it all the way to the left to save space. So now you got vector dA, what do? You need to find vector, answer the question already. Find vector AB. So therefore vector AB is equal to what?
The P plus half of the dA. Can sub in the dA.
Yes, correct. So you just have to copy and paste the dA. Then just sub in. So yeah, you already answered the question. Half times 2/3, 1/3 P. Half times 4/3, 2/3 Q. 1 plus 1/3, 4/3 P minus 2/3 Q. Okay, answer. Okay, good. AB done. Then now we have to solve for AC. Let's see. AC is what? AC in this case is, let me just draw in purple. This guy, it's AD followed by DC, which is really just 2 copies of DN. Is that useful? maybe not really. Okay, got it. How about AN plus NZ? Does that work? Yes, an intermediate. Yes?
Yeah.
But why is that useful? Because I know that AN is a vector Q, but NC is really just half of AB. Can you see?
Oh. Yeah.
It's half of AB. So that means that we can just use the answer from before, sub in the vector. What? Vector AB, right? So just copy and paste the 4/3 P minus 2/3 Q. Oops. Yeah. Sorry for the handwriting. Can? Then 1 minus 1/3, 2/3. Okay. Then not done yet because remember BD haven't find it. You want to try how to find vector BD?
BC minus CD.
Sorry, what minus what? Vector BD.
The BC
BC
plus CD.
Yeah, okay, that works. That works. Yes. BC and then add on CD. Have we found BC already? No, but we can replace it with something else.
The AD.
With AD, right? So that means it becomes okay. I need to write this down. Sorry, give me a moment to copy down this diagram. Okay, I'll put it here. Yeah. You are saying BC plus CD, but you know that BC is the same as AD, okay? And then CD is really just negative DC, right?
Negative, yeah.
Have we found those already? Let's see. I can't remember. We found DA. That's closely related to AD. How? Is it related?
Yeah.
How is it related? Negative, yes. So that means we just have to become negative 2/3. Okay, I'll just show the working. Negative 2/3 P minus 4/3 Q. Okay, maybe I'll just leave a gap here. Yeah. Then maybe I'll circle this in light green, highlight this. Oh, just negative. Okay, wait. I show one more intermediate working. This is really just equals to negative of DA and minus DC. Can? Is it clear? Can okay, then DC, do we have DC?
No.
No.
But can use AB?
Yes, correct. DC is the same as AB. So that means we can replace the DC now with AB. Over here, I hope you can see where I'm writing.
Yeah.
Over here. Then after that, you can just sub in the AB, which we already found just now. So over here, that's the AB, you just bring it in. Yeah, then you solve the question already. Okay, can I leave it to you to solve this and then I'll move on?
Can.
Can okay, good. Yes, that's question 2 done. What's the next one you got wrong? Let me see. Question 3, part 2 mistake when interpreting 0.5 half times of vector QS. Part 3 onwards, okay, just error carried forward. Let me see the question again. Okay, where's my question 3? Over here. Okay, good. You tried to draw the diagram. Okay. Let me see. Part 2. Okay, let me read the question again. The position vectors of the points P and R relative to an origin O are vectors P and vector R respectively, where P and R are not parallel to each other. Q is a point such that vector OQ is 2 times of OP, S is a point such that OS is 2 times of vector OR, T is the midpoint of QS, find in terms of vector P and R, all these different vectors. Okay. I forgot what's the mistake already. Over here, yes, you did the same thing. Vector OT equals to half of vector QS. Look at your diagram. I highlighted in purple and green. OT and QS. What's the problem?
It's not the same direction.
Yes, they are not the same direction. That's why they're definitely not equal. So right from the first step is wrong. Everything else wrong already. Okay?
Oh, okay.
Yeah. But what you actually did find a half QS, right? And then you continue to use the n minus start to simplify. That's actually vector QT. Okay? look carefully at the diagram here. QS is the dark green arrow. Then what is half of QS? You're just going, it means that you take the vector and you half its length while keeping the direction. Okay, that's what halving a vector QS means, which is what you wrote. Half of vector QS, over here. Okay, so that means that what you actually found was vector QT, which is equivalently vector TS. Now you can treat it like a free vector. Free vector meaning you can move it around in space. You got a single vector like this, you can move it around. Here, 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 anywhere, anywhere. As long as you point in the same direction and the length is the same. Oh, all these are free vectors. Can you see my blue arrow moving around? It's a free vector. It's free to roam around.
Yeah.
Okay, and they will still all be equal vectors. So it's actually QT. It will also actually be TS. All right. Okay, good. So can I ask a question? Can you see the okay right now? Can you see me moving my arrow in a circle?
Yeah.
Is it smooth or is it very laggy?
Quite smooth, can.
Okay, can. So like this and like this.
Mm.
Can now? Okay. Good. That's good. What is the next thing I want to find? Yes. So you've managed to find your vector QT or TS. But so what we can do from here is that we can still salvage your work. Just that this OT is wrong. This OT is wrong. It should actually instead just be QT or TS. Then let's just say we work with QT. Then in that case, you can use N minus start. So it becomes OT minus OQ. Correct or not?
Yeah.
Vector QT is OT minus OQ. But what is OT? OT is what we're trying to find as the subject to be found. Then OQ, OQ is something that we can guess. OQ is actually just 2p, right? Yeah. OQ is just 2p. Right over here. You wrote it down already. So I can just use it. Sorry, this shouldn't be to find now. You already found it. Whoops. I just need to use it. Then I can solve for OT already. You get that?
Yeah.
Yeah. So R minus P will be equal to QT, which is then equals to OT minus OQ. Right? N minus start. Then OT, leave it alone. OQ you found is 2P. Then just write down the R minus P. And then from here, you can solve for OT. Correct or not? Yes?
Yeah.
Solve for OT. Okay, I'll leave that. Then the rest you can do already. Your working is fine. It's just that there's error carried forward with the OT. Okay? Once you find the correct OT already, then you just do your correction for the rest. Okay? And move on. Question 3 done. Question 4, part 2 presentation. Must have algebraic notation on the left when presenting your information. Look at annotation. Alternative is to write a short English phrase describing what you just did. I will now, for example, I will now show that the vectors are perpendicular, then you insert your numerical workings. What does that mean? Let's take a look. Over here. Oh, right. Also notation. It's better to use the coordinate notation. A open bracket. It also helps you to save space. You see, your vector is colliding against your diagram already. Very confusing. Write it from left to right. It will save space and it's more correct actually. It's more accurate. What you have written over here, 14, 14, 14, is actually a position vector. Okay, it's a. Sorry, wait. Let me read the question first. Yeah, it's a position vector from point O to point A. So it's actually describing this guy. So it's not so accurate for you to put it beside the point A. What you want is to label the coordinates of that point. So it should be A 14, 14, 14, as per the diagram I've drawn over here. Okay? Can? Take note on the annotation. The other thing I want to talk about, what is it? Must have algebraic notation. So over here, in part 2, must show some algebraic notation. So here you're taking dot product, right? You don't just give me the numbers and the vectors. Give me the name of the vectors. So for example, write down a short English phrase at the beginning. OP vector dot with vector AB equals to, then you fill in with the numbers. You understand that? Must always have this kind of notation.
Okay.
Yeah. Don't have, then you must come up with your let P be the point, blah, 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 blah. If they never give you a letter to represent it, then you have to do it yourself. Okay? Do it yourself.
Okay.
Yeah, just like secondary school, let X be something, that kind of thing. Okay, yeah, that's it. I think the rest of the question is correct. Yeah. Okay, is it right? Here I got careless mistake. Okay, take note about the notation. For part 3. Sorry, I
Oh.
forgot to describe this part. Here the cap, right? You don't need because they already told you that the vector C is a unit vector. So that means that you don't need the cap. Okay, that's the minor thing. The major mistake over here is a careless mistake. You divide by the magnitude. So you should also continue dividing. This shouldn't be 14, it should be 1/14.
Oh yeah, right.
Correct, Can this one just careless,
Mm.
Okay, good. Moving on. A length of projection of A on C. Oh yeah, by the way, here you got it right, but later you got it wrong. I'm not sure why. Okay, I think I know why. Because they purposely swap the order of the dot product. But I hope you understand that dot product is actually equivalent to swapping the order around. Agree with this?
Yeah.
Yes. A dot B, B dot A, they're the same. Okay. Like just a quick example, like if this is vector A, this is vector B. You can swap it around. Of course, you're just multiplying numbers together, of course, and then you add them together. Of course, the order is the same, right? Of course, the final answer is the same, right? Yes, yeah, equal. Okay, good. So over here, what you need to understand is that this vector, whenever you look at length of projection, right, there are two main characters. This guy I like to call Michael Jackson, and then he has a spotlight shining on top of him, and he's doing his signature move, and then there's a shadow that's on the floor. On the floor doesn't have to be the exact same length as the shadow. It can be shorter, it can be longer. It doesn't even have to be length 1. This is what I call the floor. Any length. Let me just use black pen. Any length, okay? Any length. Then when you're trying to find the length of projection over here, this is what I call LOP, length of projection. It will always be the Michael Jackson dot product with the floor vector. Okay, I'll just put a vector on top of them. Modulus. Then divide by the floor. Which means that you will have Michael Jackson dot product with unit vector. Unit floor, unit vector now. Take note, here I mentioned floor any length, but here I mentioned unit vector. It's because I'm now calculating the length of projection. Okay? LOP equals to this, equals to unit vector of floor. Can? The main idea here is actually just a unit vector. So every time, then how would you describe this? Where every time you see Michael Jackson dot product with a unit vector, you will say that this is equal, this whole thing, the magnitude of this dot product is equal to the length of projection of Michael Jackson on the floor. Can you identify that?
Yeah.
Can, but how do you identify the floor? The key is the unit vector. So over here, C is the unit vector, that's why it is the floor. On the floor. Vector A is the Michael Jackson. Does that make sense?
Yeah.
Something on something. The order matters. Later on, you made a mistake. You accidentally swap them around, or it's a misconception. I'll clarify. I'll draw this diagram again. Okay. Moving on. Any other mistakes? Oh, careless mistake. This should be 84. You go and check again. Your working is okay here. You type in the calculator wrongly.
Oh, okay.
Yeah. Okay, then here, you mentioned a quadrilateral. That's correct. But maybe you should be a bit more specific. It's a parallelogram. Okay. And also the notation, vector A, vector P. Please make sure you got the tilde below. See, no tilde, everywhere, no tilde. Very bad.
Oh no. Okay.
Okay, moving on. Question 5. Part A, not answering the question to go through. A lot of bad notation. Don't have tilde. Also, you're not answering the question. You just go and consider all the different angles and then you calculate. Not answering the question. Okay. So before I go through, let me just show you this flow chart first. geometrical description of vectors. So every time there will be an angle theta between two vectors, right? Yes, angle vector, angle theta. Then what we want to consider is the different angles. So there can be 90 degrees, then we have a special name to describe the vectors. They are perpendicular or maybe orthogonal. Same thing. Synonyms. Okay, perpendicular just is the main word you should know for A levels. Then if it's 180 degrees, we'll say that they are opposite vectors. Essentially, there's a negative sign. Oh, vector A and vector negative A. Or example, vector. Let me change the font size. Or vector AB and then vector BA. Right, you swap the order around, then it's a negative vector. Okay. Then in these two cases, it is parallel. One word to describe it is parallel in both cases, 90 degrees or 180 degrees. Then over here, if it's 0 degrees, it means that they have the same angle. No special description for it. But if and in addition, they also got the same length. Same angle, same length altogether, what do we get? Equal vectors. Okay?
Oh, okay.
Just like the vector AB, vector CD just now in the square question. Okay, then here, if it's any other angles, there's no special description. Okay, there's no special description. Are we clear on that?
Yeah.
Can okay. Hold on, that's not correct. Sorry. What is this nonsense? Yeah, sorry. Please make a correction here. 90 degrees is not parallel. Sorry. Oh my goodness, what am I saying?
Oh, yeah.
Let me yeah. Okay, wait a minute. Let me redraw this flowchart. I just realized that. Oh my goodness. Okay, I'm gonna get rid of this. Vector AB. A bit confusing. To save some space, I'm gonna do this. Yes, the parallel is referring to these two cases. So sorry. Please, please remind me to send you the updated file. Don't look at the old one.
Okay.
Yeah, this one. Parallel should be 180 degrees and 0 degrees. How can 90 degrees be parallel? No. Sorry. Yeah. Okay. Yes. Oh, right. And also, yeah, those are the geometry stuff. But there's also one more fact, which is that if you got two vectors that share at least the one point that's the same, then you will say that. Oh, sorry. This is referring to the 180 degree case. Okay. Then, oh no, not 180. It's a parallel case. Okay, when you got parallel vectors, and in addition, you have that the two vectors share at least one common point, then we will conclude that two vectors are the 3 points that make up the vector is collinear.
Oh.
Can you visualize that?
Yeah.
Yeah, so there's a point A, there's a point A, there's a point B, there's a point C. Vector AB here, vector BC here, they share a common point B, and the angle between them is 180 degrees. Then that means that they are collinear. Okay, that's another way to show collinear. Okay, geometry concept done already. Now I want to talk about the question. Okay, this question, right? If you look at the answer key, they just give you one line. Vector A is parallel to vector B. To be honest, I looked at the answer key, I got a bit confused. I'm like, why is that true? Why is that true? I look at the equation they give me. How come here got bracket? Then got multiplication. So is this dot product? Is this cross product? Or what's going on? Can you understand what this is talking about?
No.
Yeah, I also got confused by it for a while, but don't worry, I'll go through now. So actually, this is really just scalar multiplication. Okay, let me just write it down. This is scalar multiplication. Scalar means what? Scalar means, for example, multiplication. Okay, so for example, 2 times of 1, 2, 3. This 2 in front is a scalar, and this is scalar multiplication. What do you do to your 2? Times into each of them, right? So 2 times 1, 2 times 2, 2 times 3. Correct?
Yeah.
You know scalar multiplication. Good. Then this is really just scalar multiplication. Can you see that? What's A dot B?
The dot product.
Yes, but more importantly, in contrast with the cross product, it is really just
A scalar.
a scalar. It's not a vector. So it's just some number. Since vector AB is a scalar, I can let K represent that scalar. K be a constant. Just to make things a little bit clearer. So we let K be the constant and we sub it in. Then we are gonna substitute this K into equation 1, the original equation they gave us. What we'll get? Vector A equal to K times vector B. Does it look familiar to you?
No.
Hopefully, yes. Therefore, we conclude that A is a scalar multiple of vector B, which means A is a parallel vector to vector B.
Oh,
Make sense?
yeah.
Right. What it means is A equal to K times B. So if this is vector, if this is vector B, then K times B will be here. Right, you multiply by K, so you basically keep the same direction, but you make it longer. And then you say that it's equal to vector A. Then what do you notice about these two vectors? They are parallel. Okay. Yeah, that's the definition of parallel vectors. Okay, yeah, so that's why. Okay, that's all. You don't need to do all this working. Okay, that is for okay, maybe you need for the second part. Let's read the question first. So you got question 5. A and B are non-zero vectors such that they give you the equation. State the relation. They are parallel, okay, between the directions of A and B, and find modulus of B. Okay, let me present to you my way of doing this. If I can find some space, I can't. No space. Where should I do my working? Okay, I'll start a new page. Hold on a second. Okay, so over question 5 part A, I'm going to do it below. Let's move on. So question 5 part A. Okay, question 5 part A, let's take a look. So we already found out that vector A is parallel to vector B. So we are going to now try to find modulus of B. That's our goal. So I'm going to refer back to the equation again. What we have is vector A equals to A dot B scalar multiplied by vector B. Correct? Yes, good. So what we want to do next, I think what we can do here is we can dot product by B on both sides. What do I mean? Here's one way that I thought of, slightly different from the solution. I'll take the dot product on both sides of the equation. Okay?
Okay.
Then what happens? What's B dot B?
The modulus B squared.
Yeah, so that means that I can just copy and paste this, but replace the modulus B with modulus B squared. Then this is a scalar. Modulus is also a scalar. Let me write this down. Scalar. This one also scalar. But more importantly, let's do one extra modification here. On the left-hand side, A dot B, I'm just gonna multiply it by 1. Is that fair? Correct, right? Scalar multiplied by 1, nothing changes, right?
Yeah.
Then what do you notice? Compare left-hand side and right-hand side.
The modulus B squared is 1.
Exactly, that's all. Ta-dang! Easy.
Oh.
Yeah, that's all. Okay, then modulus B can be square rooted. Then you need a plus minus 1, right? So of course modulus B. Oh, sorry. Let me think a little bit. Yeah, correct. Modulus B. Okay, modulus B would be -1 or modulus B would be +1. Can? That's it. Your answers. Can? Okay. Let me think a bit. Can it actually be negative? No, you have to reject this one. Because by definition, modulus of a vector, is just square root A squared plus B squared plus C squared, right? Positive square root. So there is no negative. So this one is reject. Modulus is always positive. Or 0. Can? So there's only one answer, positive one. Okay, now let's take a look at your answer. Something went wrong. What happened? The notation. Oh, wait. Part A is not. Oh, sorry. That's part B. Sorry, part A, you didn't attempt that part of the question. So never mind. I'll move on. Let's see. This is question 5. Okay, then part B, what happened? Tricky because the angle given is 5 pi by 6, not acute. This is a rare question. Okay, yes, over here your diagram is wrong. Your diagram is wrong. This is a non-standard question where the angle between the vectors is 5 pi by 6. What is it in degrees? Can you tell me what is 5 pi by 6 radians in degrees?
150.
Yes, correct. 150 degrees. So I think you can tell straight away that your angle here is wrong, right? 150. This is definitely too little. So the correct diagram should be something like this. Michael Jackson is over here, and the floor is on the right side of Michael Jackson. That's okay, because the floor actually represents this entire line. It goes forever in the left and right. Then our length of projection will still be here. He's not falling into the abyss, dropping down. No. There is still a floor below. And there's a sunlight on top, or some sort of light source, and it's casting a shadow, and that's your length of projection. Can? Okay, so let's see how we can actually solve this question. Okay, question 5, part B. So we have that diagram already. Length of projection. Okay, your length of projection working is actually okay. 3/2. Okay, I think I don't need to write so much. Length of projection formula, you get 3/2 is fine. Luckily, because the formula works regardless of whether you have the diagram or not. So 3/2 is correct. But then the projection vector, now something is wrong. What was wrong? Actually nothing wrong. Sorry. Yeah, you are correct. Yes, 3/2 of vector B is correct. Even though your diagram is wrong, but because there is not much use of diagram when you're using the formula, so your answer is still correct. Okay, this part. Okay, projection vector. I don't know if I explained this before, but projection vector is basically just taking the length of projection and then you multiply that, or rather you take the length of projection, you divide by the length of the floor, length of this vector B, which is basically modulus of vector B, and then you multiply by the vector B itself. Did I mention that?
Yeah.
Can, huh? Okay. Can, yeah, then that's projection vector. Next one, we want to find out the modulus of 2a plus b. Okay, over here, you made something you wrote something very scary here. You wrote down modulus of vector 2a plus b is square root of the square. Okay, here you are not allowed to write down the square of a vector 2a plus b. Okay, there is no such thing. This is illegal notation. There is only dot product or there is cross product between two vectors. Right? 2a plus b is a vector, 2a plus b is another vector. You only dot product or you cross product. There is no such thing as square. There is only the square of modulus. Okay? So here the problem, what's a better way to present this would be, the better way to present it would be square root of the modulus of vector 2a plus b square. Modulus is a scalar. Scalar, you square it, then you take the square root. That makes more sense. Is that clear?
Oh, okay.
Yes. You cannot square the vector itself. You can only square the modulus. Square the modulus. Modulus is a length. Okay, vector, there's no such thing as squaring a vector. Doesn't make sense. There's only dot product or cross product. No such thing as squaring a vector. So this notation is very, very illegal. Wrong. Okay? Can, but then the rest of the working is fine. Just the notation wise. This one, I think in the answer key, they wrote down omission of modulus signs during working. Yeah, so here, let me write it down in pink. Here, you omitted a modulus sign. Okay, must have modulus before you square. Can?
Can.
Okay, moving on. Yeah, okay, I don't need to go through. Yeah, your answer is correct. Okay, next, let's see. Question 6, part 1 incomplete could also be 0 vectors. You said that, okay, let me read the question first. Question 6, part 1. Given that A cross B is equal to 0 vector, what can be deduced about the vectors A and B? Okay, you wrote that they are parallel. Maybe it's my mistake. I never explained this case as well. Vector A and vector B could also be 0 vectors. Correct? 0 vector cross with anything will just be 0. Yeah. So you need to consider these cases as well. Okay. And then part 2. Wow, very scary notation. How come you have tilde inside the components of a vector? Never see before.
Oh,
That means you have vector inside a vector. Wow, that's some complicated stuff. It's very complicated. It's like R3 cross with R3 cross with R3, and then you power 3. Wow, this one Cartesian product. It belongs to this family. Okay. This is definitely not in your syllabus. You cannot have vectors inside vectors. No. No. And by the way, this notation, you can ignore it if you are not studying math.
okay.
Yeah, I can just ignore it. Never mind. So yeah, those insides are 3 real numbers. You shouldn't put the tilde. Okay. But anyways, your method actually works, but you left out one key information. After you take a cross, you let the unknown vector be ABC, and then you take the cross product, you get this. You simplify, you get 3 equations. Correct. But you are missing a 4th equation that's key to solving your question. So what I did for you is I rewrote it nicely. You see, my ABC, I always make sure they are in the same column. So that it's neater. When I key into GC, I won't get confused. Okay, I use my GC, then I get this as my answer. Do you need me to show you?
No.
Don't need, Okay, good. Trust me on this one. This one, C equals C is basically your X3 when you type in the GC. Then you realize that, hey, this is what we call a free parameter. Free variable. The C can be anything. If you only use 3 equations here. Which means that there is insufficient information. We need at least one more equation to help us to solve for C. Then we can substitute it. And that missing information here is, if you read the question, 6 part 2, what did it say? What did it say? Find what vector?
I never opened the thing.
Oh, please go and open the question. Can open a solution as well. 0, 1 vector solution. 6 part 2. Let me know when you're ready.
Oh.
Yeah.
Unit vector.
Unit vector, right? Exactly, because it's a unit vector. So go back to this. You got all this working, but then you know it's a unit vector. What does it mean? It means that the modulus is equal to 1. Correct or not?
Yeah.
Then I can square both sides. Luckily, squaring 1 still stays as 1. Then now I get a squared plus b squared plus c squared equal to 1. Take note that this cannot be keyed into a GC. This cannot be keyed into a GC because there are more than 1 variables, and the power is not 1, it's power 2. You cannot use your poly simultaneous number 2 function anymore. This has to be solved by hand. So let's see how we can do it. We got A, we got B, we got C. Here, everything is in terms of C. So what can you do? Substitution. Can you see? A is negative 0.5 C, so I replace it here. B is negative C, so I replace it here. C is just C, so leave it alone. And sum of square equal to 1 from this equation. Can you see?
Can.
Then after that, I can just solve for C. Blah, 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 expand out. I get 0.25 C square plus C square plus C square. Then add together, I get 2.25 C square equal to 1. Divide by 2.25, I get 4 over 9. Use a calculator. Take the square root, I get 2 over 3 of negative 2 over 3. Then those are your 2 possible values of C already. Then you just substitute in accordingly to find your A, B, and C. Your A and B. And I was lazy, I didn't do the work, but you can work it out yourself. What's the corresponding value of A and B when C is the positive 2/3? I showed the working for the case where C is negative 2/3. Okay, then you'll get these two answers. So your method works, your method works. It's just that you didn't go all the way. You got the equation and then you stopped. You didn't continue. Are we clear on that?
Yeah.
Okay, are you copying?
Yeah.
Oh, sorry. Okay. Yes. Your method works. You're just missing this information here, unit vector, and then you must be smart enough to realize you can do a substitution to solve the equation. But there is a faster way, which is what is given by the solution. Right?
Oh, okay.
Yeah. What did they tell you? They tell you that the vector n in this case is a unit vector. So that means its length is 1. Then does it mean so okay, I don't have space here. I'm gonna start a new page. Oh, it's gonna cut off. Wait a minute. Let me think a little bit. How can I? Okay, I'm gonna add a new page here. What is the question I want to go through here? It's question 6, part 2. Okay, so what they told you here is that. Oh, maybe I should write down part 1 first. Okay, from part 1, what we concluded is that whenever you got A cross B equals to 0 vector, it means that there are 3 cases. Vector A is parallel to vector B, vector A equal to 0, or vector B equals to 0. I should put or in between all of them. Okay, then part 2, they tell us that we got a vector n that's a unit vector. Unit means what? Unit means that the length is equal to 1. So length is really just what? Square root A square plus B square plus C square. Notice I never put tilde because I know it is, because I am telling you it is not a vector. Here I put tilde to tell you that it is a vector. Very different. Please take note of that.
Okay.
And over here, can I ask you a question? Make a quick guess. Do you think it's possible for A, B, and C to all be 0? Meaning that vector n, can it be a 0 vector while still being unit vector?
No.
Impossible. Right? 0 square plus 0 square plus 0 square gives you 0. Square root 0 will give you 0. Then it cannot be a 1. Unit vector, unit. So that means that vector n is not 0 vector. 0 with a light tilde below is referring to 0, 0, 0. Okay? So it's not a 0 vector. So it means it cannot be this case. It cannot be this case. By elimination, it can only be this case whenever we got a cross product with a vector n. Assume that vector A is n. Okay?
Okay.
So that means that in part 2, they gave us the equation that vector n cross with the I plus 2j minus 2k 1, 2, negative 2 equals to 0 vector. The vector n here is not a 0 vector, which then implies that using part 1, from part 1, vector n is parallel to vector 1, 2, negative 2, which means that vector n is equal to k times of 1, 2, negative 2. Is that okay?
Yeah.
Okay, good. So in that case, if we know that they are parallel, then what do we want? Here they are telling us to find a unit vector n. So that's how can we do that? How can we do that?
The A cross B equals to 0.
Okay, so I used that information already, and then I deduced this, right? So I can't go back again. I cannot go back already. This is the new information. How can I continue? What's the information that's not used yet? I can use again, actually.
1, 2, negative 1.
Negative 2, you mean? 1, 2, negative 2.
Oh, yeah.
Yes, sort of. Basically, Yeah, correct. We need to use that information in the sense that vector n here is a unit vector. Correct or not?
Yeah.
So that means that the modulus of n is equal to 1. Agree so far?
Yeah.
But if you take modulus of n, it's the same as modulus of k times 1, 2, negative 2. Right? Yes?
Yeah.
Okay. Then now how to solve for k? What you can do here is, please take note, when you got modulus of us, maybe it's my fault. I never explained modulus well enough. I just assume that you know it. But basically, modulus of, like, let's say vector A dot with vector B, you cannot do anything except for swapping them around. It is not true to factor out like this. Please don't do this. This is totally wrong. But it is true if you got a scalar in front, let's say a lambda times a vector A, you can factor out the lambda like this. So it becomes modulus of A times modulus of vector A. So this is true. Let me show you an example. You got negative 2 times 1, 2, 3. You take the modulus. What does it mean? Two ways to go about it. First way using the rule would be modulus of negative 2 times modulus of vector 1, 2, 3. Let's check what is that. Modulus of negative 2 becomes positive 2, multiplied by modulus of square root 1 square plus 2 square plus 3 square. Is that okay with you?
Yeah.
Leave that alone. Now let's try the other way. We times the negative 2 inside first. So we get negative 2, negative 4, negative 6. Then you take the modulus. What do you get? You get negative 2 bracket square plus negative 4 bracket square plus negative 6 bracket square. Take the square root. Can you double check with me? Use a calculator. Check that they are the same. Let me know once you're done. Yes, no?
Yeah.
Same, okay, convince, this is just one example to convince you that yes, this rule does work. You multiply lambda into A first, then you take modulus. It's the same as you factor it out. Factor out the scalar, like the negative 2 here. But make sure that you must have modulus around the negative 2, so it becomes a positive. Ken, are we clear on that?
Yeah.
So that means that now I can, let me just move this down. That means that I can now rewrite this as modulus of k times modulus of the vector 1, 2, negative 2 equals to 1. Over here, you need to find out the modulus of the 1, 2, negative 2, which is what the question was doing. You realize that it will just be square root of, it'll just be 3. Okay? So modulus k times 3 equals to 1. Okay? Maybe over here I should say sub n equals to k times 1, 2, negative 2, in case you forget. Let me just highlight it. Here is purple color. Here's vector n. Here's purple color. Sub. Okay, then after that, you can solve for k. So modulus of k will be 1 over 3. So k equals plus minus 1 over 3. And then you can now sub the k back into the original equation. I'll call this 1. So sub into 1. Technically, I'm being lazy. I should be sub k equals to plus minus 1 over 3. So therefore, we get vector n equals to plus minus 1 over 3, 1, 2, negative 2, which is really just a lazy way of saying vector n equals to the positive version or vector n equals to the negative version. Can? Can? Okay, so again, your method does work originally. Over here and here, you're just missing the second part involving the unit vector. Then you can solve for C. But what you realize is sometimes you might not be able to know how to solve this kind of equation. You must do by hand substitution. So that's why they offered a alternative solution, which is this one.
Mm.
You need to deduce that they are parallel, so you can rewrite it as k times the vector. And you need to use the fact that the modulus of the vector n is 1 because they told you it's a unit vector, and then you just substitute in. And then you use the modulus rules to help you to simplify. And then solve for k. Opening up the modulus, have to introduce plus minus. This is from O levels, I think. So yeah. Opening up the modulus must have plus minus. Okay, that is question 6. Anything else from question 6? Let me see. Wrong tutor used in wrong place. Incomplete answer. Did not use the unit vector clue. Yeah. Okay. So yeah, you didn't use the unit vector clue over here. Okay, I went through already. That's all for question 6. Moving on. Let me know if you got any questions.
Okay.
If not, I will just move on.
Okay.
Okay, good. Question 6, part 3 is okay. Question 7. Question 7. Part B, careless. First component of cross product wrong. Idea correct. Equate each component from left-hand side to right-hand side. Let's see. Okay, your part A is fine. Part B, careless. Should be a negative 3y. You wrote down y plus 3.
Oh.
Do you understand?
Yeah.
Can so it should be multiply y with negative 3 minus away 0 times z. This one minus away that one. Down minus down. This way minus that way. So y times negative 3, not y plus negative 3. And then minus away 0 times z. That's a negative 3y. Are we clear on that?
Yeah.
Okay, then what you'll get here is, yes, you got the idea correct. You got vector equal to vector, so you can equate them. You get 3 equations. Okay, I see that you understand that, but you never carry through all the way because you already found out, there's an error. You got confused. You didn't identify this careless mistake. Okay, but here is how you do it. Once you equate them, you can solve for y. Y is equal to 0. Then you can let z equals to lambda. Okay, because here is extra variable that cannot be solved. It's what we call a free variable or free parameter. You have to replace it with lambda, where the lambda can be any real number. My sharing is paused. Oh my goodness. Did you see my working? I mean, okay, I didn't write anything. I showed you the screen.
Yeah, okay.
Can see, wow. Oh, sorry. Okay. Yeah, so this part here, where did you last see my working? Do you see this part? Do you see this part?
Yeah.
Okay, what else? Did you see this part?
No.
No. Okay. Oh, I was okay. Sorry. Let me try again. So what I'm saying is, when I take the cross product, first component you got careless. It should be down minus away up. Down minus down. This way minus that way. So it should be cover up the first row. Then you look at y times negative 3 minus away 0 times z. Which is negative 3y. But you gave me a y minus 3, which is wrong. Should be negative 3y. So error carried forward. And you understand the idea that you got vector equal to vector, so you compare component wise. Which means that you get this. Okay, you got the idea. But then error carried forward, that's why you got it wrong. But the more important thing here is that after you get to this step, solving for y equal to 0, you have to let z be equals to lambda, where lambda is any real number. Any real. Why? Because we don't have enough equations to solve for z. You see, when we have minus 3y equal to 0 and minus y equal to 0, there's no new information given. Both cases will give us y equal to 0, which means that now we have 3 variables but only 2 equations. That is not enough. When you got 3 unknown variables, you need 3 equations. Are you clear on that?
Yeah.
Like 2 variable and 2 equation, 3 variable, 3 equation. Here, there are 3 variables but only 2, which means one guy will be left alone. Very sad. Not enough information to find out the last guy. He'll be left alone. Then this one you have to bring him back to the family and make him turn into a lambda. Lambda will be any real number. He has the freedom to roam around because there is no third equation that's restricting it. So that's why it becomes a lambda. Anyways, after substituting with lambda, we get 3x plus lambda equal to 2. Solving for x, we get this 2/3 minus 1/3 lambda. Y is 0, z is lambda. Then we can now rewrite it in set notation. Now, technically, this is, I don't think it's really in your syllabus. I learned this in university. So, do you really need to know this? It's in the answer key. I think I'll just explain. Okay. So basically, in set notation, you just need to tell me what are the things that are inside the set. So this is the type of thing that's inside the set. X, y, z, points. Your what we call a tree tuple. Three components we call a tree tuple. An element of a family. Here R3, right, you definitely don't need to know. It's not in your syllabus yet. It's in further math. Element of R3 means you're what? You're inside the 3D space. The family of all the three tuples. Okay, this is to describe what is inside, the type of element that will be found inside the set. And then the element x, y, z, it follows a certain rule. This is what we call the rule. You don't need to know this. Okay, disappear. And what's the rule? The rule is whatever you found for the x, the y, the z. The x, the y, the z. And that's your answer. You can also present this rule as what you've seen in the answer key. X, y, z equals to, just put it component wise. I didn't do this because I don't have enough space to do it, but I'm still doing it now, so it doesn't matter. You can also write it as a vector, also perfectly fine. Okay, that's a set notation. I definitely don't need to know this. What's more important is this part here. You need to interpret that, oh, this is actually just a vector equation of a line. Right? Vector equation of the line. Right. There's a point, and then there's a lambda times of a direction vector. So yeah, and then you must interpret. It passes through the point 2/3, 0, 0, and it's parallel to -1/3, 0, 1. This is what I call the direction vector. It gives you the direction of the line. Can? Interpretation? Okay, good. Then that is question. What question is that? This is question 7b. Okay, 7b done. I think. Yes. Move on. Okay, let me see. Let me think a little bit. Okay, I'll just move on. Okay, Ken. Let's see. Question 8. What's the mistake here? Nothing. Question 9, question 10 also perfect. Very good. Let's move on to question 11. Part D, never draw picture. What happened? You never draw picture. Very bad. Must draw picture. Okay.
Okay.
Yes. Every question, please draw a picture. Okay. Question 11. Let me see. What is the matter? Oh, that's not part D. That's a sad face. I totally forgot. Okay, never mind. Yeah, just make sure you draw a picture. Okay, part 1 and part 2, I think is okay. Part 1, just note that the equation of a line, you don't present it this way. The fraction part should be equal to each other. They are both equal to lambda, right? So they are equal to each other. And then there's one that's on its own, not equal to lambda. You just put a comma, then put y equals 4. This is the way to present it. Can?
Okay.
Yeah, okay. Good. I'm gonna move on. Part 2, also correct. Okay, move on. Part 3, question already mentioned foot n, so you should use the n. Be consistent, don't come up with your own variable f. Are you clear on that?
Yeah.
They already use, here, over here. You use f when the question already mentioned n. So try to follow the question, okay? They use the letter n, then just follow them. Don't come up with your own letter. Okay? Can, yes. Well done in finding the foot, but forgot to answer the question, perpendicular distance. You forgot to answer the last part, find the length of this vector Cn. You work so hard to find the vector On already, then you forget to answer the question. Ayya. ATQ. Answer the question. Okay?
Okay.
You see, I'll show you the working. Yeah, so you found vector O and then you never continue. Yeah, I'm sure you know how to find this, right? Vector Cn, just take the On minus OC. Actually, it's over here already. 10 plus 3 lambda minus 5, then 5 plus 4 lambda. And then after that, you find the length. Take the square root A square plus B square plus C square. Can?
Can.
Can. Also, by the way, do you need me to recap with you how to do this? Convert into 5 root 2?
Don't need.
Don't need, Okay, good. Then I'll move on. Can. Question 12. Not sure if I read wrongly or did you write down the vector OA wrongly first and then you somehow got it right, correct again later. Very funny. Over here, your vector OA, you write down for me 1, 3, 3, correct? But then later on, when you're doing the working for the dot product, you use 1, 2, 3. You auto correct yourself.
Oh yeah, I never changed the working.
Okay, yeah, I don't know what's going on, but okay, that's good. Make sure you auto correct during the A levels. Make sure you do this. You get it wrong here, but then somehow in the next one you get it right. Okay, good. I don't know how your brain works. How come it will be inconsistent? Okay, just do that. Make sure you get it right during A levels. Okay, you got the concept right. So it's fine. Or maybe notation wise, you should put a theta equals. Oh, you wrote down theta equals. Okay. Can next one, 12 part A. Part B there, what happened? Correct. 12 part C, also correct. Okay, very good. 12 part D, you missed out a 6 over here. You accidentally forgot to write down a 6 when you're arguing that this will be always positive and therefore it's not equal to 0. Right? Yeah, left out 6. Then 13 part 1, you never answer the question. There was one part that wasn't labeled part 1, part 2, part 3. Then there's a portion before part 1. They ask you to find the value of alpha and the acute angle. Okay, you left that out. And also, diagram is incomplete. You did not include a point A and a point B. This is the complete diagram. Can see? Question 13. Let's go on to question 13. Stare at the diagram, copy it down. I think you should copy down on your paper and pen first.
Okay.
This diagram is the translation of whatever English words they gave you. The equation of the line L is R equals 137 plus T times 2 negative 15. So I label a line capital L here. Then there's a point 137 and a direction vector 2 negative 15. The points A and B have position vectors 9, 3, 26 and 13, 9 alpha. So I label a point B, point A here, the coordinates, not the vector, just the coordinates. And you see it's very neat and tidy. Doesn't intersect with the line. When I try to draw a vector, that's not correct actually. You should draw a coordinates. The line L intersects the line through A and B. What is this? The line through A and B. It's a separate line. It's a totally new line. Letter L subscript AB. And it intersects at point P, sorry. Can you understand the English?
Yeah.
Can. Good. Then now you want to find alpha and the acute angle between line capital L and AB. So this guy and this guy, want to find this angle theta and you want to find the value of alpha. Ready? I'm gonna start a new page. Yeah. Okay, let me add page. I'll just copy down the diagram. Okay. So this copy and paste. What's the question number? Question 13. Question 13. Okay. Then this is the part before part 1. Okay, let's see. How do we solve this question? What you need to interpret first is, let's list down some of the vectors we know. So you got the vector OA, 9, 3, 26. You got the vector OB, 13, 9 alpha. What else you have? That means that you can find vector AB. I think you managed to find that. Okay, so it's just OB minus OA. N minus start, OB minus OA. So you just fill in the blank. Subtract 13 minus 9, you get a 4. 9 minus 3, you get a 6. Alpha minus 26 become plus 26. 4, 6, 26. 4, 6 alpha plus 26. Is this correct?
Yeah.
Wrong. I copy wrongly. Here is a positive 26. I wrote down negative. Sorry. Should just be a alpha minus 26. Sorry, I was careless. Okay, so you got 4, 6 alpha minus 26 as your vector AB. That means that this vector AB can be your direction vector, so you can find the equation of line AB already. Right? Take note, every time you write down LAB dot dot, what do you have to write next? When you start off vector equation of a line.
R.
Yes. Is it just R?
Like equals.
Tilde. Draw your tilde. Make sure you remember this. R tilde, then equals. Okay. Sometimes you leave this out. Very bad. No. Must leave it in. Leave it in.
Okay.
R equals, then you must have a point that lies on the line, and then you got a direction vector parallel to the line. So what's a point? Maybe we can pick the one that doesn't have an unknown alpha. I'm very scared of unknowns. Very, very scary. Because they are not numbers. I'm more familiar with numbers. So I prefer this one, 1920x1020. Oh, there's a point A plus lambda times, okay, I'm just going to follow the answer key. They use S times of direction vector. In this case, I can use AB. Correct or not? Vector AB is parallel to line AB. Of course. Then I can just use the direction vector for 6 alpha minus 26. 4. Do I put sum? Do I need to put sum?
Don't need.
Don't need. You do not. Not just don't need. It's cannot. You cannot put sum. Cannot. Because sum means it's a specific value. That's not true. S is any value. This is the equation of a line. It is not a point on the line. Only when it's a point on the line, then you put for sum. Okay, so R equals to whatever. Then that's line AB. We are not done yet because what do they tell us? There's a point of intersection P, right, between this capital L and LAB. Right? So let me just shrink this down a little bit. What did they tell us? They tell us they intersect. So LAB and L intersect at point P. This implies that if I can just rewrite this as 9 plus 4s, 3 plus 6s, and 26 plus s times alpha minus 26. This part, is it clear? S bracket alpha minus 26 and plus 26?
Yeah.
Can, Okay, good. Therefore, we get this vector here to be equals to the vector for capital L. Okay, maybe I should also write it down. L here would be R equals to a point, which is the 137, plus the T times of the direction vector 2 minus 1, 5 for T element of real numbers, which is exactly equal to, just simplify it as a single vector, 1 plus 2T, 3 minus T, 7 minus, 7 plus 5T. Correct?
Yeah.
Yes, right? Okay, then we can copy this down and equate. Okay, equate. Then you just compare component-wise. Make sure when you start off the line AB, you use a different variable. Okay? Every time you're trying to find a point of intersection between two lines, you should use two different variables, S and T, or lambda and mu. Lambda and mu. Make sure you use different when you're finding point of intersection between two lines.
Okay.
Okay, carry on. So now we can equate them piece by piece. I advise you to straight away write down the three equations. Don't simplify yet. 9 plus 4s equals to 1 plus 2t. Stop. Don't simplify. I know you can see the 9 and 1 cancel off, become an 8. Don't do that yet. Go on to copy down equation 2 first. Gather all of your information first before you do your algebra. Equals to 3 minus t. Stop. I know you can see 3 and 3 can cancel off. Don't do it yet. Don't do it yet. Leave it alone. Copy down the third component. And then let's try to be neat and make sure my equal signs are aligned in the middle. Then equals to 7 plus st. Okay. Then I like to draw a curly brace like this to group them together. Okay, they are one family. 1, 2, 3. Then now this implies that I draw a curly line again. They are one family. I start to simplify. 9 and 1 cancel off. Okay, maybe I'll put a S together like 4S, then 2T I bring over. Actually, let me just double check. Do you do this working at all? No, you didn't. Okay. In that case, I'm just gonna continue going through. Yeah, so continuing. 4S and then 2T I can bring over. So I get 4S minus 2T equals to 1 I leave alone, 9 I bring over. 1 minus 9, negative 8. Then 6S and minus T. Maybe I'll just leave my 6S alone here. Minus T bring over become plus T. Then 3 over on the left go to the right. So 3 minus 3 becomes a 0. Likewise over here we got what is it? Okay, this one I would want to simplify at the side. S times alpha minus 26S equals to 7 plus 5T. Notice that I'm purposely making my S on the left and T on the right already. So continuing with that pattern, I got alpha times S. Okay, this is alpha S. Minus 26S. Oh, so maybe I should have just left the alpha minus 26 alone. Yeah, you know what? I'm just gonna leave it alone. Alpha minus 26 bracket S. 5T bring over, get minus 5T equals to 26. I bring over becomes a 7 minus 26. 7 minus 26 on a calculator gives me a negative 19. Okay, then I can try to solve for S and T and alpha. Okay. So let's see. I can simplify a bit more. So what I do, you see, all that I did was first line turn into the first line, second line turn into the second line, third line turn into the third line. I don't write it like messily, like a left line. This one 9 plus ST, then I write down my working directly below and then directly below. And then suddenly I bring in my second equation and then I simplify. And then, oh, suddenly my first equation, I can do something. Then I transfer over. Then I write down the second thing. It's very messy, you see. If you do it that way. Here, I offer to you a nicer way to present it. Draw curly brace, copy down the 3 equations. Then within the same row, you keep to the same equation. And you just simplify. Don't go and substitute or don't elimination or substitution yet. Don't do that yet. Simplify as much as you can. And then you draw a curly brace to group them together to make sure that all 3 equations are being used. Clear so far?
Yeah.
Okay, continue simplifying. Notice that the first equation, 4, 2, 8, I can simplify into 2 minus 1, then minus 4. The rest, I will copy and paste it. Yes, I know it takes time to copy and paste it, but I think it's worth it. It's worth the time. Makes you less confused. Then finally, now that I have this updated system of equation, I call it 1, 2, and 3. What do you notice about 1 and 2? If I add them together?
Like cancel out.
Cancel off the T, then the 6S plus 2S gives me just 8S. Equals to minus 4 plus 0, negative 4. Solving, S equals negative 4 over 8, negative half. Can?
Can.
Good, moving on. Now that we have S, can we solve for T?
Can.
So we can sub S equal negative half into which one?
The second one.
Sure. First one also okay. But definitely not the third one. Definitely not the third one because there's still an unknown alpha. So sub S equal negative half into equation 2, we get 6 times negative half plus T equals to 0. Make T the subject. 6 times negative half is negative 3. Bring it over, become positive 3. Can?
Yeah.
Good. So now we got S, we got T. Can we solve for alpha? Which equation should we use?
The third one.
Exactly. We use 1, you use 2. Now we have to use equation 3. So sub S equals negative half and T equals to 3 into equation 3. What do we get? Let me copy down the equation 3 first. I'm running out of space. Yeah. So yes, good. Now I just need to substitute in. So this is just for reference. You don't need to do this because my iPad screen is quite small, so I need to copy and paste it down. Okay, alpha minus 26 multiplied by S, which is a negative half, minus away 5 times T, which is 3, equals to negative 19. Simplify, negative 15. Simplify, negative half alpha. Minus become a plus. 26 over 2 is 13. equals to negative 19. Bring the minus 15 over, you get a negative 4, I think. Correct or not? Minus, bring over, become plus 15. Minus 15 minus 19 is negative 4. Yes?
Correct.
Okay, then therefore you're left with oh, there's still a 13 here. And then you still need to subtract 13. Okay, you know what? I'll do all of that in one step. No, not all in one step. I'll do it step by step. 13 minus 15 is negative 2 first. Then I bring the negative 2 over. So I will get a plus 2, which is negative 17. Then I can just multiply by negative 2 on both sides. That will give me my alpha. Then this will be positive 34. Correct?
Correct.
Can then that's your answer. Are we done? No, we still need to find the what? Tell me. Read the question. Question 13. The questions you conveniently skipped. Question 13. Try to open on your laptop. Find the acute angle between line L and AB, right? So this theta here, you need to find it. How? I think you know, direction vector. Can I leave it to you?
Okay.
It's basically just finding out the direction vector, which is vector AB. You already found out what's alpha. So alpha equals to 34. Maybe I'll use a different color to indicate that this working came from a different time zone.
Yeah.
It came from the future. Okay, so alpha equals 34. So therefore, vector AB is equal to 4, 6. Then 34 minus 26 is just a 8. So 4, 6, 8. Then that means you got a direction vector 4, 6, 8 here. And also you got the direction vector 2, negative 1, 5. What can you do with them? Use the cosine formula to go and find your angle. Okay. Of course, you can use a shorter version of 4, 6, 8, like 2, 3, 4, as long as it's parallel, right? Direction vector only cares about the direction, not so much about the length. Especially when you're using it to find the angle. You can use a shorter version if you want, but there's no point to doing that. Just use 4, 6, 8 and 2, negative 1, 5. Use the cosine formula, solve for theta. You can read the answer key.
Okay.
All right, good. Then moving on. Question 13. First part, okay already. Anything else I need to cover? Let me see. What is this? Cannot find my question 13. Question 13, okay, part 1, okay. Part 2 also, find the reflection of the line. Not so okay. This one. Okay, actually, you're working. Okay, actually, your working is correct. Were you able to visualize this in your head?
Like I visualized like the way I draw my diagram.
Oh, this one. Because I don't see your line. The line and the whoop reflect about the line L. I didn't see that.
Oh.
But you end up giving 137 plus lambda negative 504, which means that you know that there is a point X, a point 137 somewhere. Here you wrote down 137, but where's your 137 exactly? Can you draw for me on your diagram? Like use the annotate function. Where is your 137?
I never draw the line. I think the line I draw here.
Oh, that's your 137.
Yeah, I think this one is my line.
Oh, okay, that's the original line. But what the question, did you know that the question is actually asking you to consider not the purple line that you just drew, but rather there is a arbitrary new line that passes through the X, like this. And then, passes through like this. And then you reflect this green color line, so you get this new line. The goal is to find out what is this new line. Did you know that's what the question was asking you to do?
I don't think so. I never draw.
And then I'm afraid you might not be able to replicate this. You might have gotten lucky. Okay, then I explain this question. Okay. Let's read the question first. Question 13, part 2. Find the position vector. Question 13, part 2. Find the position vector of the point of reflection of the point C about the line L. Okay, this is the standard ratio theorem question. You could do it, the C prime, and you got it right. Yes, -433. Good. Hence, find the reflection of the line passing through point C and the point 137 about the line capital L. Capital L is what you draw over here, and also you use a small L, which is wrong. That's not correct. Should be capital L. Oh. So yeah, your notation is wrong. Yeah. So what that means is that reflection of the line passing through C and point 137. So there is the original line passing through C and the point 137. So what I did is I started off by drawing my capital line L. Then I label the point X. I let X be 137. And since I know the equation of line L is what? 137 plus T times 2 negative 15. It means that this 137 must lie on the line L. Is that clear?
Yeah.
Okay. Then they tell you the line passing through C and the point 137. So it's this line here, LXC. Is that what the question is asking you to find the equation of? This guy?
Yeah.
Wrong.
Huh?
Find the, what's that word? Read. Hence find the
Position vector.
no, hence find the second sentence already.
Reflection of the line.
Reflection of the line passing through C and point 137 about the line L. Okay? So what does it mean? Are we trying to find LXC?
No. Find the reflection.
Find the reflection. This guy, LXC prime. Okay, I call it prime for reflection. That's what the question is asking you to do. So it has to be this line. I hope you can tell. This one is just geometry, okay? Whenever you reflect something about the line, the distance from a midpoint will be the same. Okay, that's why it's called a midpoint. So that's why, more importantly, this reflected line will pass through C prime. Are you clear on that?
Yeah.
Can Okay, good. And also because it's a reflection about a line L, as long as this original line passes through a point on the line, you reflect it, it will still pass through that same point. Do you agree with this point?
Yeah.
Can Okay, so therefore this line has it will pass through 137, it will pass through C prime. Let me just write down what C prime are. -433. Okay, so you know it passes through 137 and -433. Can you find the equation of the line now? Can, and that's exactly what we are about to do. Okay, and that's exactly what you're supposed to do. Maybe you interpreted it correctly this way. Maybe you understood it because your working was actually correct. But it will be advisable for you to draw a picture so you can double confirm you know what you're doing. Can? Okay. And also label these kind of, just draw a diagram and label all these points like LXC prime, LXC, C prime, and all those other points. Yeah, okay. I don't know how you got the question correct, but I hope you understand what's going on. I'm gonna move on already.
Okay,
let's move on. Question 14. There is no square root of a dot product. Talked about it already. Yeah, same mistake. Midpoint is not accurate. It's a position vector OM / position vector ON. Oh, okay. Here, wrong notation again. Yeah. There's missing modulus. Should be modulus here. Okay. Modulus. Illegal notation. There is no square of a vector, only dot product or cross product. Nothing else. No square root of a dot product as well. Okay, good. This one is an improvement because I remember my homework 3 or homework 4, I can't remember. You couldn't do this type of question. Like you have to move a few steps forward, few steps to the left, 4 cm on the side length, all that. But this time you can do it, which is good. Okay. Just a thing to take note. here, exclamation mark, vector OM equals. Here, you should not say midpoint of C and V. That's wrong. Okay, this is wrong. Whenever you say point, right, it's referring to coordinates. Here, we are not finding out coordinates, we are finding out a vector. So it's actually the position vector of the midpoint of C and V. The position vector associated with the midpoint. Okay, so to not talk so much English, get rid of this, just write down OM. Okay? Vector OM. Is that clear?
Yeah.
Can, that's vector OM. Then the other one is also similar. You shouldn't say midpoint of A and B. No, you should just say vector ON. Vector ON. Can then be extra clear what is vector ON? Look back at the diagram. Start from the point O, move towards the point N. This vector. Okay. Anything else I should talk about? Okay, this one just neater way of presenting. Yeah, about the three equations. Just try to write it as I already went through just now the system of equation. Your working is quite messy. Yeah. You started off with equation 3, and then after that you do a substitution without mentioning you are doing substitution. You didn't say sub what into what. You just do it. So it's quite confusing. I have to think a bit. Oh, then I realized, oh, you are replacing the t with z using equation 3. Oh, equation 1. Oh, so it's quite messy. You're working this part.
Oh, okay.
Try to label your equations like 1, 2, 3. At least you can go and check my working just now. That I've written previously over here on the right side. Let me know if you got any questions. Then for part 3, okay, actually, what question are we at now? We are still on question 14. Oh my goodness, I need to go faster. Question 14, part 3. Okay, nothing much. Just over here, vector VB, you wrote down OB minus OV, that's correct. You simplify that, that's correct. But then you write down equal to 0, that's not correct. You shouldn't write down equal 0 so quickly. It should be the dot product that's equal to 0, right?
Yeah.
This one not 0 yet. No, not yet. Wrong. Okay, only equal to 0 after dot product. Okay, moving on. Yeah, you reject negative square root 2, that's correct. Here you wrote down an equal sign after cosine inverse, that's totally wrong. You have to put, you shouldn't put an equal sign. Cosine, you see, it's always like, for example, cosine theta equals to 1 over 3. Then theta equals cosine inverse of a number, usually a fraction. There's no equal sign in between cosine inverse and a number. Why you put equal sign here?
Oh.
Your notation, your cosine inverse notation is wrong. Take note of that. Yeah, just notation. But you got the idea correct. Okay, good. Moving on. Question 15. Let's see. Question 15. Vector VB is not equal to 0. Only write down equals to 0 after taking the dot product. And also your cosine inverse notation. Right, I think that comment was meant for question 14. Question 15, there's nothing much to it. You got it right. Yeah, okay, I'm gonna skip question 15. Whoops. Yeah, question 15 is correct. Sorry, in my feedback, I think I wrote down my feedback for question 15 wrongly. It should be for question 14. The vector VB not equal to 0 part. If you are reading that, it should be for part 14. Vector VB is well done. Supposed to be well done.
Oh, okay.
Yeah. Okay, can never mind, I just update it and send you later. Okay, then question 16. Part 2 only. Your answer is correct, but may I know what are you confused by? Also, you forgot to draw a picture. Very bad. Never draw a picture. But you could answer correctly, so okay, fine. Here you draw question mark, but your answer is correct. I don't know what you're confused by. Do you remember? It's perfect.
Oh, I probably thought my answer not correct.
Okay, can then yeah. Good. Well done. Be more confident. You're correct. Okay, moving on. Nothing, sure?
Yeah.
Okay. Question 17, refer to, then the rest is all correct for question 16. Well done. Okay, then question 17, refer to vectors homework 2, question 9b. Do you know what is that? Homework 2, I went through in class. Question 9b. So the strategy here is to find out the equation of the line and then find the point of intersection between the line. But you must you must write down the equation of the two lines of line AE and line OB in terms of vector A and in terms of vector B. So I think I should just go through lah. Let's read the question. Question 17. So okay, I don't think I have time to go through the worksheet part, the homework 5. I'll go through on Friday. Is that okay?
Okay, but when will we start a new topic?
Yes, we should be starting new topic already. I was actually planning to start on Friday, but then I am running out of time. Is it okay if I start on Friday? I will spend 1 hour on vectors homework 2, homework 5, sorry, and then after that I'll start a new topic. I will move on to complex numbers. Is that okay?
Yeah, can.
Can Okay. Yes, complex numbers. I'll give a crash course. I think you're quite good at complex. You can do your prelim paper that ASRJC one. I see that you can do complex numbers. Okay, Ken. So let's just move on. Question 17. Points A and B have position vectors A and B respectively, referred to an origin O where A and B are not parallel to each other. Point C lies on AB between A and B and is such that AC over CB is 2, and D is the midpoint of OC. The line AD produced meets OB at B. Find in terms of A and B the position vector of C. Part B we'll read later. So you got your part A correct. You just have to use ratio theorem for OC, and your diagram is also fine. Good, your diagram is correct. Then okay, then we move on to part B. Find the vector AD. Okay, that's your first question. So what do you realize about vector AD? It's really just OD minus OA.
Yeah.
Okay, and I think that is the strategy I want for. Oh, sorry. Yeah, correct. It's OD minus OA, and you managed to find out what is OD. It's just half of OC. If we just copy down the diagram. Never mind. I'll just zoom out faster a bit. So OD is half of OC. Then that means that we just need to half the 2/3 B plus 1/3 A, which we found from part 1. And then we can get our OD. That's correct. Good. Then you just need to find AD by taking OD minus OA. That's correct. Okay. So you managed to find vector AD, but then now the OE over EB and the AE over ED you have trouble finding, right?
Yeah.
So the strategy here is we're gonna look at we're gonna try and find out what's length of OE and length of EB indirectly by finding out vector OE and vector EB. Okay, let me just show you the conclusion first. Vector OE will be 2/5 B, and vector EB will be OB minus OE, which is 3/5 B. Okay. I'll explain later how I get these two vectors. I'll explain the conclusion first. Then the strategy here is, even though we what we've done is we've rewritten it in terms of vector A and B. Of course, in this case, just B. Oh. Same thing here. I just copy and paste. Then here we want to find OE over EB. It's really just the length of vector OE over length of vector EB, or the magnitude, or the modulus. But what do we realize? We realize that this is really just, you can factor out the 2/5 from the vector from the vector OE, right? The scalar can be factored out when you take modulus. 2/5 take out. Then that's how I get a 2/5 modulus B here on the numerator. Then at the denominator, I have modulus of vector EB, which means that over here, vector EB is equal to 3/5 of vector B. If I take the modulus, it will be the same as modulus on the other side. Then the 3/5 can be taken out to become modulus of 3/5, but 3/5 is already positive. So that's why maybe if I just write it out, it will be clearer. It's just modulus 3/5 times modulus of vector B. But modulus of a positive number is still a positive, so I can now drop the modulus. So I'm left with 3/5 of modulus vector B, which is what I have at the denominator here. Then what do you notice about the modulus B and modulus B?
They can cancel out.
Then you're left with 2/5 over 3/5, which is 2/3. That's the answer. That's how you get it. Is that clear?
Yeah.
The strategy here is to factor out our common factors that can be cancelled off without directly finding out what is the length of vector b. See, so the length of vector b doesn't matter. They will just cancel off. Is that okay so far?
Oh, okay.
That's a trick. You must factor out a common factor, then cancel off. You cannot directly find the length. And it must be everything in terms of A and B. That's a strategy that I thought of. It's different from the answer key, a little bit different. And I feel that it's more standard. It's a little bit more standard. You can use this in many questions. Okay, so yeah, so you get 2/3. But how did I get these two answers in the first place? OB is obvious, but OE, how did I get OE is 2/5 B? Let me show you how I did it. We go back to the diagram. We want to find out vector OE. Sorry, position vector OE, which is really just the same as finding out the coordinates of E. Then what do you realize about point E? It's the point of intersection between AE and OB, correct?
Correct.
So that means that I can find out the vector equation of line AE, vector equation of line OB, then I just solve them simultaneously. Correct or not? Finding point of intersection between lines, you know how to do that.
Yeah.
So we'll do that. So let's see. I say that E is the point of intersection between line AE and line OB. So line AE, I find its equation. R equals, it passes through the point A, so OA, plus lambda times of vector AD. I don't have to do AE. I can just use the letter D, because direction vector only cares about direction, not the length. Is that clear?
Yeah.
Okay, good. So that is vector, that's the vector equation, but we now rewrite it in terms of A and B. So OA is just vector A, AD is just, we found it just now, I think. It's OD minus OA. If I'm not wrong, it was here, yes. Over here, 1/3 B minus 5/6 A. Yes? Remember? That was the part B. They asked us to find the vector AD first. So I'm just recycling whatever we found. Yeah. Recycle. Then I put it over here. Okay. Mic test, can you hear me?
Can.
Okay. Please give a response, because I didn't hear okay, then I'm afraid my audio disconnected.
I did, but I think it didn't pick up.
Oh, okay, sorry. Yeah. Yeah, I'll just keep asking if I cannot hear a response. If not, I'll start talking to myself. Very, very scary. Okay, so 1/3 B minus 5/6 A. Then in this case, what you need to do is make factor out all of the vectors, vector A, and factor out all of the vector B. Group them together. So you see here, you can times the lambda into each of them. I skipped a step, I didn't do it. Then I just see straight away, here's one copy of vector A, here's lambda times negative 5/6 copies of vector A. I combine them together to get 1 minus 5/6 lambda times vector A. Is that clear?
Yeah.
Then now you have vector B, lambda times 1/3, positive lambda times 1/3. So you get 1/3 lambda B. So that's how I get my line, the vector equation of line AE. This guy here. Are we clear on that?
Yeah.
Good. Then how about line OB? It will again be vector R equals to a point on the line plus some scalar times a direction vector. Take note that the scalar, you have to use a different letter. Just now I use lambda, now I use mu. Okay?
Okay.
Then point, since this is vector OB, sorry, the line OB, it passes through the point O. So I can just use the origin, which means it's 0, 0, 0. I can essentially ignore it. In the world of vectors, the 0 vector is like a 0 in the real numbers. So you plus a 0 vector is the same as ignoring it. Then you just mu times of vector B. Mu times vector B. This is vector equation of line OB. Is it okay?
Yeah.
Okay, so you got the vector equation of line AE and vector equation of line OB. What do? R equals R equals? Equate them.
Yeah.
Substitute. So that's why you get the line AE equals to line OB. Maybe it would be more accurate to say equals to vector OE for some lambda and some mu. Okay, must always have the sum. Right? That's the point of intersection. But I think this is a bit extra lah. Never mind lah. You can solve for you can write this down already. Very good already. Huh? you can think of this is already very good. Get the vector equation of the two lines, then equate them to solve for solve for lambda and mu. So how do we solve for lambda? How do we solve for mu? In this case, I purposely factor it out as something times A plus something times B equals to something times B plus something times A. The reason why I did that, right, is because I can now compare coefficients. Do you see that this is actually just an invisible plus an invisible 0 times vector A?
Yeah.
So this is 1 minus 5, 6 lambda times vector A. This is 0 times vector A. So I can compare coefficients, sort of. Then I get 1 minus 5, 6 lambda equals to 0. Likewise for my vector B, 1/3 lambda B, mu times lambda B. Sorry, what am I saying? Let me try again. 1/3 lambda times vector B equals to mu times vector B. So therefore, I conclude that 1/3 lambda is equals to mu, the coefficients. Is this part clear?
Yeah.
Okay, good. So therefore, you can now solve for lambda. You get 6/5, right? Do I need to show the working?
Oh, don't need.
Okay, then therefore 1/3 lambda, good. Then therefore 1/3 lambda equals to mu. I know my lambda is 6/5. I substitute in 1/3 times 6/5, cancel off, and I can simplify mu equals to 2/5. Is this clear?
Yeah.
Okay, then 6/5 and 2/5, honestly, I just need one of them. In this case, I can use either one. I'm just going to use mu equals 2/5. Why? Because now I can solve for my vector OE. I just need to use either equation 1 or equation 2. Using mu equals to 2/5, I substitute over here, then I conclude vector OE is 2/5 of vector B. Okay? Then the rest of the working I already explained just now. Don't need to explain again now. Is it okay?
Yeah.
Okay, it's the same thing, right? Yeah. So I start from the conclusion, then I fill in the middle. Yeah, because this part is quite long-winded. Okay, but this is the part that you should know, the conclusion. That is finding out vector OE only. So we got 2/5 B, and then eventually finding out OE over ED. We are not done. We still have AE over ED. Let's go. Okay, AE over ED. This one actually slightly easier. Why? Because AE can now be broken down as n minus that OE minus OA, which is 2/5 B. We found out just now minus OA vector A. This part, I can't really do anything. So I'm just going to leave it alone. Why did I find the vector, by the way? I'm trying to find AE over ED, which is a length over a length. Why did I find the vector? Because I can then later on rewrite it as the length of the vector divided by the length of the vector. Right? That's what I'm trying to do. Oh, so I want to find length of vector AE. But this one, not much information. What can I do? Can I split it up like this? Can I split it up? Length of 2/5 B minus A, I split it up as 2/5 B minus away the length of vector A?
Cannot.
Cannot. This is not correct. You just track with some simple example like 1, 2, 3, 4, 5, 6. 2/5, 1, 2. Yeah, I'll make my life easier. Put in a more zeros. 0, 1, 3. Okay. Why choose such big numbers? Just put 0. Check the modulus of this guy versus I don't know, 2. Yeah, just the same thing but inside. But the modulus is outside. Like this, and then you minus away modulus of the other one, 0, 1, 0. I don't think they are equal. I hope they are not equal. Let's see. Not equal, huh?
No.
No, okay. So basically, yeah, you cannot split up whenever there's a plus or minus. You can only split up when it's, for example, lambda times of vector B. You take modulus, it's modulus lambda modulus vector B. Like I explained just now. This is the only thing you can do. Or yeah, that's essentially all. That's all you can do for vectors. Later on, complex numbers, you will also learn another version of modulus for complex numbers, but it's different. Take note that one more thing. In the world of vectors, for modulus, if you have vector A divided by vector B, this is illegal. Illegal. There is no division of vectors. No division of vectors. Can?
Can.
So that means that since this is illegal, it also means that the modulus, okay, I'm gonna throw this away. It means that the modulus of vector A divided by vector B is nonsense. This is nonsense. Okay, no such thing as division by of vectors. So modulus of division is nonsense. If you write down this and then you equal to modulus of A over modulus of B, this one is possible, but this one is nonsense. And therefore they are not equal because the left hand side is irrelevant. This is just out. This is also out. Are we clear on that?
Yeah.
Can So here, when I write down later on, I write down this modulus divided by modulus of a vector, it's still okay. It's still legal because I'm taking scalar divided by scalar. Okay, moving on. AE, we cannot do anything. So it's modulus of AE also cannot do anything. So we just leave it alone. Let's find out our other vector, ED. ED will be n minus start OD minus OE. Yes?
Yeah.
But what's OD? OD we already found out just now from part. Actually, we haven't found it. Let me double check. Oh, actually, we did. You found it over here. Half of OC. So 1/3 of B plus 1/6 A. Just put that over here. Then minus away OE, which is 2/5 of B. Right?
Yeah.
Then you just subtract, you simplify, you get negative 1 over 15B plus 1/6 A. Then how? Remember, you must remember, the ultimate goal is to find a ratio. And when we find a ratio, what's the key trick here? What's the key trick?
Find like a common
Factor.
Yeah.
Common factor from the top and bottom, which can cancel each other off. So over here in ED, do you notice that actually I could have factor out negative 1 over 6? I give you a while to think about it. Is it equal?
Yes.
You can multiply out. See, is it correct or not? Confirm?
Yeah.
Check already,
Mm.
Convinced, Okay, so therefore we get a negative 1 over 6 times of 2/5 B minus A. What is so special about 2/5 B minus A? What is this?
The AE.
It's AE. So this is actually just negative 1/6 of vector AE. So I skip a step. I take the modulus. I will get modulus of negative 1/6 multiplied by modulus of 2/5 B minus A. And then I replace the 2/5 B minus A with vector AB. Oh, I also simplify the negative 1/6 as positive 1/6. Modulus of negative 1/6 as positive 1/6. So I get 1/6 times of 1/6 times of the modulus of vector AE. Sorry, that was a typo over here. Should be an E here. Okay, good. So that means that I now have 1/6 times of the same thing, which means that when I take the ratio AE over ED, it's vector A modulus of vector AE over modulus of vector ED. Modulus of vector AE cannot do anything, but the denominator here can be replaced with 1/6 times of the modulus of vector AE. Okay, AE. I think it's my handwriting. E looks like a B. Okay, then the AE will cancel off. You're left with 1 over 1/6, which is a 6. Is this part clear to you? 1 divided by 1 over 6 is 6.
Yeah.
Okay, now then that's your answer. Okay.
Okay.
Yeah, that's the strategy. Okay, go back and review this question as well as this homework 2 question 9B. I think I gave you the solution already. Go and find the PDF. I'm not gonna find for you. Question 9B and the video. Okay, that is question 17. Let's move on. Question 17. Oh no, so many questions. Okay, question 18, part C. Need to know properties of quadrilaterals. What is this question? Okay, this one, yes. Part A and B is fine. Part C is not okay. You didn't try this question. What you need to know is this is the diagram they're asking for. OABC, then you got all these midpoints. And then you need to figure out that vector MN and vector QP, they are parallel and equal. Okay, of course, in the world of vectors, when you say equal, straight away is parallel and same length. Parallel and same length. Once you have that, you can have a parallelogram. Can you see?
Yeah.
Let's think. 2 lines that are parallel but different length. What shape is this?
Trapezium.
trapezium. But now if I specify that they are parallel, but not just parallel, they are also same length. Oh, let me just copy and paste this. Copy and paste. So parallel and same length. And then I join the four sides. What shape do you see?
Square.
Square. This is a square, 90-degree, man.
Rhombus.
Not as okay. Maybe I should have placed it a bit far away. Sorry, let me try again. Okay, this and this parallel and same length. Join the ends together. What shape is this?
Parallelogram.
Parallelogram. Yes. It's just a coincidence that it's a rhombus. If I put it close together. But just need to know that rhombus is still a parallelogram. A rhombus is a special kind of parallelogram where the two sides here, where all four sides are equal. Okay. Yeah. So yeah, just need to show parallelogram. You just need to show one opposite pair of sides are equal vectors. And how do you do that? Let's just take a look at the answer key now. Do you see the answer key?
Yeah.
So over here, they already told you this. So what is our goal? We want to show that vector mn is equal to vector qp. So what can we do? Vector mn, you realize is on minus om, n minus start, right? Then vector on, what do you see? It's actually just half times of OA plus AB. Why? Why is? And then minus away OM. Okay, you know what? Let me just change back to my iPad. I need to annotate this. If not, it's a bit difficult to explain. Can you see my shared screen?
Can.
Okay, good. So let's just go through this. So mn is on. Oh, no space. Wait, let me add a new page. Oh yeah, by the way, it would be good if you use one page, one foolscap paper site for one question, so that whenever I have to add a new page, it won't disrupt the flow.
Oh, okay.
Yeah. Okay. Anyways, let's just write it down. This is question 18C. Sorry, do you need to rush off?
Don't need.
Don't need. Okay, Ken, I'll just move on. Yeah, so what we realize is that vector mn is actually just vector on minus om and minus start n minus start. But what is on over here? On is actually just let me see. It's just OA plus AN, right?
Yeah.
Minus away OM. But wait a minute, what's OM? OM is just, can you make a guess? What is it?
Half of OA.
Very good, it's half of OA. So therefore, we can rewrite it as OA plus AN minus away half of OA. OA minus half OA. You're left with just
half
OA. Can? Okay, very good. So that means that we can now replace with, is this correct? Actually, let me think a little bit. Am I doing it wrongly? Let me just double check first. ON is OA plus AN. What is the goal here? It's just half of OB. That's not correct. Let me think a little bit. Sorry. Sorry. Give me some time to think about this.
Okay.
Plus AN. Okay. Okay, I'll leave this alone first, then I'll move on to vector QP. Can I move on to vector QP? QP in this case, I realize it's just QN plus NP.
Yeah.
QP here is QN then NP. But what is QN? QN is actually just the same as OA, right? QN over here, OA over here.
Yeah.
Midpoint, midpoint. Can all? Okay, then I replace with OA plus NP. Hmm. Let me think a little bit. Am I want to express everything in terms of OA and AN? How do I do that? So okay, my goal here is to rewrite it in terms of OA and AN. So I already have my OA, so I leave it alone. But NP, how do I rewrite it in terms of AN? Let me think a little bit. I'm a bit confused by their solution. Can I do OP minus ON? Would that help? Okay, let me try again. I'm so sorry. Restart. This is MN is ON minus OM. Okay, then ON I'm going to leave it alone. But the OM here, I'm going to rewrite it as half of OA. Is this okay?
Yeah, can.
Can, good. I rewrite it in terms of ON and OA. Then here, NP, I'm going to rewrite it as, okay, let me start from the top. Vector QP is QN plus NP. So that means that I can rewrite it as Q, yeah, it's QN plus NP, but the QN is the same as vector OA. Right? So I replace it. Then the NP, I leave it alone first because I don't know how to solve it. But I think I can rewrite it now as OP minus ON. Does that help? Is that the same? First, yes, right? N minus start.
Yeah.
Okay, then what we realize is that here you got ON, OA, here you got OA, ON. What's the odd one out? OP, right? So we need to rewrite OP in terms of OA or ON. How can we do that? OA or AN? Let me think a little bit. I'm missing out on a certain property. Oh, right. I'm missing out on a certain property. I'm missing out on ratio theorem. Do you notice that okay, I'm just gonna rewrite it as my OA minus ON plus OP. I'm just swapping around. Swapping around. But then OP here, do you notice that there is this triangle here and a duck feet? So actually the ratio here is 1 to 1. So you can use ratio theorem, right, to find vector OP. What would it be?
The OC plus OB over 2.
Yes, okay, good. So that means I can substitute my OP here with OC plus OB over 2. Does that help? Let me think a little bit. Okay, I got it already. I am so sorry for wasting your time. Let me try again. I'm gonna restart from the top. Is that okay? Sorry about that. I am so sorry. Okay. Okay, I understand already. Okay, good. So we start off with the vector mn. We know that it is just on minus OA om. Vector on minus om. Yes?
Yeah.
N minus that. But here vector on, let me erase all this. Here vector on is really just trapped inside this triangle here. Let me draw it out for you on a separate diagram. Vector on is over here, and it's trapped inside this triangle here. Can you see the dark feet?
Yeah. Can.
Okay, dark feet. So that means that vector on can be expressed as half of OA plus AB. Right? Because n is a midpoint. So there's a 1-to-1 ratio. So OA plus OB 1 times divided by 2. So I can replace my ON with OA plus AB. Or rather, if I simplify straight away, half OA plus half OB. Right? That's my vector ON.
Yeah.
But what's my OM? In this case, OM, if you look at the diagram, OM is actually just half of OA. So that means I can replace it with half of OA with a minus in front. Is that okay?
Yeah.
Okay, then what do you realize? Half OA and minus half OA?
Cancel out.
You're left with half of OB. Okay, so it's in terms of OB now, using ratio theorem. Can
Can.
Not done yet. We got MN in terms of half OB. We are not done yet. Now we need to find our vector QP. Vector QP, you need to show that it's also equal to half OB. How? Here's what we can do. Again, you do the same trick, n minus that. So it's, let me see, did I get the diagram right? NPQ. This is just OP minus OQ, right?
Yeah.
Okay, then OP in this case, let's see, it's just trapped inside. If I just draw on the diagram itself, it's trapped inside this triangle here with a dark feet here, vector OP. Can?
Can.
So that means that vector OP is nothing but, if you use ratio theorem, half of OC plus half of OB. Is that correct?
Correct.
Yes, ratio theorem?
Yeah.
Then minus away vector OQ. But what is vector OQ?
Half of OC.
Yes, correct. Half of OC, because it's over here and OC is in the same direction. It's just a shorter version. I mean, OC is longer and OQ is half the length, but same direction as OQ. So we can replace with half of OC. But don't forget the minus sign in front. Then you just copy and paste the rest. Maybe I should also mention here, I am using ratio theorem on vector OP. Here, and then the other one, same thing, also ratio theorem. Also using ratio theorem. Okay, that is half OC plus half OB minus half OC. What happens to the half OC? They will cancel off. So you're left with half OB. There we go. Both of them are equal to half OB, which implies that, let's just conclude, MN equals half OB equals QP. Since these two vectors are equal, therefore we get a parallelogram. Done. That's all.
Oh, okay.
Yeah. The opposite sides are equal in length and parallel. It's the same as saying that the vectors are equal. Okay, and therefore you get a parallelogram. Okay, that is question 18C. Can I move on?
Can.
Can. Okay, good. Then question 19 was well done. I'm going to skip it. Question 20, part A, misconception. OM is not half of PQ. Here. Yes. OM is Huh? OM is not half of PQ. Over here, you wrote down OM equal half of this fella here, 3/5 minus 1/3 A, which is PQ. That's not correct. Do you see? Look at your diagram here. And then look at OM, look at PQ. Blue color and yellow color. What do you notice about these two vectors? They are the direction. Are they the same?
Directions.
Different directions. So are they equal?
No.
Or are they half times? Cannot, not equal. Even though M is a midpoint, you might think you want to times half. Okay, if you times half, what happens? You're just taking the yellow color vector PQ, you times half, you're only getting a shorter version, still the same length. So you're just getting vector PM or vector MQ. Okay, vector OM is not half of vector PQ. Half of vector PQ is just vector PM or vector MQ. Are we clear on that?
Yeah.
Okay, good. So that's why this question you have to use ratio theorem. In this case, vector OM is actually just OP plus OQ divided by 2. You see that? The dark feet? Ratio 1:1. Then you can just substitute in your OP and OQ. 1/3 A, 3/5 B, then divide by 2. Simplify, you get this 1/6 A plus 3/10 of vector B. That's your vector OM. Or part 1, to answer part 1 of question 20.
Yeah.
Okay, and not done yet. Now you want to show that the area of triangle OMP can be written as K times of the modulus of A cross B, where K is a constant to be found. Your idea is correct, okay? Your idea is correct. It's just that your OM is wrong. Use the correct OM and do your own correction. You will get the correct answer. However, what I realized is that here you got very lucky. Even though your final answer for OM is wrong, right? It's actually just off by a negative sign. Do you see that? Here it's positive 1/6, but here is negative 1/6. Then somehow in the working, you got lucky. The A cross A is still equal to 0, even though there's a negative sign here when it should be a positive. So that's why your answer, final answer, will still be the same. You got lucky. Okay, are you clear on that? You use up your luck here, then your A levels no more luck. Oh no. Kidding. No. Just make sure you're accurate. You're using the correct theorem. You get the idea, right? It's not, OM is not half of PQ. OM is found using ratio theorem. It's not half of PQ.
Yeah.
Clear? Okay, good. Moving on. Part B, misconception, length of projection. Identify Michael Jackson and the floor. Floor will always be the unit vector, so need to phrase your answer correctly. So over here, they ask you, you have a cap dot with a vector B. How do you interpret this geometrically? You said that it's the length of projection of a vector OA onto vector OB. That is inaccurate. It should be OB onto OA. Do you know why?
No.
Because here the unit vector, if you read the question, this is question 20. The unit vector, where is the question? Find part 2, part A. Give a geometric interpretation for A dot B. The vector A is the unit vector. Okay, so actually here the cap shouldn't be here. This is wrong. No cap needed. Here, you can reinterpret it as modulus B dot with vector A. Also, you didn't put a tilde. Oops. Okay. And then A is the unit vector. Remember just now I went through with you, Michael Jackson on the left, then the unit vector on the right.
Yeah.
That's a floor. This is the Michael Jackson, this is the floor. So it will be, since the question told you that A is a unit vector, therefore it should actually just be vector B, the Michael Jackson, casting a shadow onto the floor, vector A. Which is or if you phrase it more formally, it will be the length of projection of vector B onto vector A. All right. And also, maybe you shouldn't use OA and OB because the question used little a and little b. So you should stick to the same notation. You should instead say, if I just change this, it should be vector B onto vector A. Can?
Can.
Can, yeah, I wrote some notes for you here. Michael Jackson on the left, floor on the right. Because this is unit length. The one that is a unit length will always be the floor. So onto the floor. No, your English grammar must make sure your order is correct. Okay, can part B? Is part B okay? Length of projection?
Yeah, can.
The order is wrong, swap it around. Okay, part C is fine. Moving on. Question 21, last question. Did you, not the last question, sorry, still got a few more. Did you misread the question? The question asked for area of triangle OAB as well. You're not answering the question. You look at your working. Look at your working. You draw a triangle ABC, but you didn't draw a point O for me. And then you use half of do you understand what you're finding here? What are you finding? Area of what?
Area of ABC.
ABC, okay, that means you read the question wrongly. Because the question initially asked you to find the area of triangle OAB. Show that the area of triangle OAB is half of the modulus of A cross B.
Yeah.
Area of triangle OAB, not ABC. So you misread the question. The trick here is to use the O levels area of triangle formula, half AB sine theta. Do you remember this formula from Trigo? Emax.
Yeah.
Half AB sine theta. I prove it to you over here. Very extra. You don't need to know it. But just need to know the formula. It will not be in the formula list anymore. Must memorize. Half AB sine theta. Sine rule and cosine rule also need to memorize. Then occasionally you need to use it. And here's one example of an occasional use of it. So what you need to realize is that in triangle OAB, it's just half AB sine theta. Then that means that you can reinterpret as length of vector A, length of vector B, and then sine theta. And since theta is always in between by definition, 0 degrees and 180 degrees, the angle between two vectors. And if you look at the sine theta graph versus the modulus of sine theta graph, y equals modulus sine theta, you realize that from 0 to 180 degrees, which is the left side, domain, you restrict the domain to just the 0 to 180 degrees, they are the same. Sine theta and modulus sine theta, they are the same. Which means that sine theta here can be replaced with modulus of sine theta. And over here, there's an invisible times 1. Times 1 is really just the length of a unit vector. And cap, which is a normal vector. Then therefore, you can reinterpret this entire thing as this entire thing. Half times the modulus of mod A mod B sine theta times a unit vector n. When what's that? What is this fellow? It's nothing but the definition of A cross B. Okay. Then therefore you have also with a modulus. So therefore you get half of A cross B, which is really just the area of triangle, which is what the question was asking for. Yeah, you have shown. Okay, shown. I should put down SHOWN. Next one, you want to deduce an expression for the area of triangle ABC. Just refer to answer key. I'm going to refer you to the answer key. Half of A vector AB times cross with vector AC. Your working was correct, but it's just that you didn't manage to get the conclusion they wanted. Or rather, an expression. So it's not there's not only one correct answer. There's a few possible ways to do it. I think what you did was, is it correct? Actually, yeah, it's correct. Sorry. Let me double check. Something funny. B cross A and B cross B here. Is that what you wrote down?
Yeah.
Wrong. How come you change the A to a B? You should keep it as a A. Just keep it as a A. Nothing happened to the A. Yeah, then in that case it will be correct. Yeah, you're correct. Good. A cross A is 0, yes. A cross C, you swap the order around, you introduce a negative, double negative become a positive. Correct, correct. Very good. Yes, and this one is not square bracket, should be modulus. Okay. Accident. Okay. Yes, you're correct. Oh, I didn't check this part. Sorry. You're correct for this part, front part. Then after that, you hence or otherwise show that the perpendicular distance from point B to AC is this formula here. I actually gave you a similar question in homework 2. I asked you to try it yourself. But I don't know if you tried it, but it's the same question now. It's a very famous formula. They always use it, but don't try to memorize it. Learn how to derive it on your own. They will not ask you to memorize this. You are not required to know this formula. So the trick here is really just to reinterpret the area of the triangle. So what is the triangle we're focusing on? Is it ABC or OAC or OAB?
ABC.
What is the triangle? ABC. Yeah, so focus on this triangle. So maybe I just get rid of the irrelevant triangle here. ABC, in this case, what you realize is that it's just half times base times height. Specifically, the height being vector AC. Sorry, the base being vector AC, length of vector AC, and the height being this yellow part here. Okay?
Okay.
And what is this yellow part here? It is what the question is asking for, the length D, the shortest distance, perpendicular distance from point B to AC. You realize that?
Yeah.
So this perpendicular distance from B to AC that the question is asking you for is the height of this triangle, perpendicular height of this triangle with a base AC. So using formula of half base times height, you can just rewrite it as half times D times modulus of vector AC. And that is one interpretation of the area of the triangle. But from the previous part, we also found an expression for the area of the triangle. Then now we just need to simplify and solve for D. Okay. Okay, let's do that. Yeah, there's really nothing much to it now. Here AC you can rewrite as OC minus OA, but following the notation of the question, it's just vector C minus vector A. Notice I also put the tilde here. Must put the tilde. You want to make D the subject, so half bring over, you times 2. Okay, actually don't need. Half and half, they will cancel each other off. You times 2 on both sides of the equation. So let's simplify that. Half, I get rid of it. AC, I replace with C minus A, OC minus OA. Just use the question's notation. So I use C minus A. Then how do I make D the subject? Oh, by the way, this is not a cross multiplication. This is just a normal multiplication. Scalar and a scalar. So it's just normal multiplication. So I am safe to divide by C minus A. Right? Dividing by C minus A, what do I get? I'll get the answer. I'll get the final answer, which is shown. Shown. Okay, just to be more strict, if you really want to be super strict, the D should be on the left and then the other guy should be on the right. But I don't think that is necessary. I think this is perfectly fine. This is also fine. Shown. Okay.
Okay.
All right. That is question 21. Not done yet. Still got question 22, 3, and 4. Question 23 can skip. Question 22, what is it? Cartesian equation need to include a z equal to 0 as well if we are talking about 3D equations. Technically, for this question, they are always talking about I component, J component, which means that this is actually just a 2D question. You can do it on an X and Y plane. No need the Z. Don't need the Z axis. So that's an unrealistic question. So it's better to interpret this as a 3D question, which means that there's a hidden Z equals to 0. So in your equations, right, you kept on missing out on the Z equal to 0. So please include that as well. Comma, then Z equals 0. Alternatively, you can also put down A and D, end. Okay. Z equals 0. And that's all. That's the only thing. I don't think you make any mistakes with this one. Yeah, you just missed out on the 0, and also a careless mistake over here. You know, careless mistake over here, it should be a half. Okay, x equals to 3 plus half lambda. This should be a half. 3 plus lambda times half. Okay, can. Then this one, part E, you circled. You want me to go through? Okay, I will go through. So the trick here is you want to, let me read the question. Passing it, you're trying to find a vector equation and Cartesian equation of the line passing through the point 0, 4 and parallel to the line 3x minus y equal to 4. The trick here is 3 steps. Let me start a new page. Give me a second to start a new page. I will start it over. Oh, where's a good place to start this? Yeah, maybe I'll do it over here. Oh, this is bad. Oh. This, where should I do this? Okay, I'll do it over here. What question is this again?
22.
Okay. 22 part E. Okay. Question 22 part E. You got a line. It's passing through the point 0, 4. I'll just put in an extra 0 for the Z component. Treat this as if it's a 3D vector question. And it's parallel to the line 3x minus y equal to 4. So this is the line we're trying to find. But then there is a given line L, capital L, 3x minus y equal to 4 that is parallel. This is to be found. This is our goal. So what you need to do first is to convert this guy into from Cartesian form. This is Cartesian form. With z equals to 0. You have to convert this into the vector form. Okay, so let's do that. How do you do that? What you do is you will rewrite the hold on. Let me think a little bit. Okay, got it. Yes, what we can do is 3x minus y equal to 4, so we can rewrite as 3x equal to y plus 4. Oh, so that means that we have x over 1/3 equals to y plus 4 over 1 equals to lambda. Then we can rewrite as x over 1/3 equals to lambda. So x equals to 1/3 lambda. Likewise, we also have y plus 4 over 1 equals to lambda. So we have y equals to 1 times lambda minus away 4. This is plus 0. And then don't forget the z equals 0. So altogether, we now have x equal 1/3 lambda plus 0, y equals 1 times lambda minus 4, z equals to 0. Combining together, vector r is equal to xyz vector. Substitute in, you get 1/3 lambda. Okay, can I just skip a few steps? I'm just going to factor out the lambda first. 1/3, 1, and 0. And then you add on the constants. 0, -4 for y, and then 0 for the z. Is that okay?
Yeah.
Not too fast, huh? And then you still need for lambda an element of real numbers. Rewriting it nicely as a point on the left plus lambda times a direction vector on the right, just to make things easier to see in standard form. So r equals to this. That is my line capital L that was given. What is the most important thing here is the direction vector. We don't care so much about the line, we care about the direction vector. 1/3, 1, 0. So we redraw it on the diagram. Where's my 1/3, 1, 0? Maybe somewhere here. Doesn't matter where it is, just make sure it's parallel. 1/3, 1, and 0. So step 2 done already. Step 1 and step 2 done already.
Yeah.
And then now you do step 3. Use the point 0,4 and direction vector from step 2. Find the equation of line. So we're going to use this fella. We're going to use this point. We're going to find the equation of the line L. I think you can conclude already. So what's the equation of the line? R equals? A point? What point?
The 040.
040 plus?
The direction vector.
Maybe you use a different one. Let's say mu times?
1/3, 1 and 0.
What do you write here? For
mu equals to real number.
Oh, not equals to. This one is an element of. Oh, you forgot your sets already.
Yeah.
Oh no. Element of means it's a particular element inside the set. Okay, you won't really be tested on this in A levels, H2 max, so it's fine. You can get away with it. Just need to know that you're supposed to draw an E like this. Curvy and then line in the middle. Element of the set of all real numbers. Yeah. Okay. Can then that's the equation. Done. Okay, 22E done. Next one. Go. Question 23, perfect. Don't go through. Question 24. Part 1, don't drop the modulus on the numerator. What's that? Oh, yeah. Here, I think you did this in a previous homework as well. you drop the modulus. Here there's modulus. You cannot drop the modulus when you bring the cosine over. Okay, what you did was you didn't write modulus. You should over here.
Okay.
Can must have modulus. Yeah. Then after that, however, fortunately, what you did was you square both sides of the equation. After you square, yeah, you got lucky, because everything becomes more than or equal to 0, which means that you don't need the modulus anymore. Okay, technically it should be modulus here, and then you square the modulus, which happens to allow you to drop the modulus. Okay, so it turns into round bracket. Yeah, but anyways, your working up to here is correct. But then wow, your A, B, and C, your quadratic equation, here you put 16 wrong. You read the wrong equation. Should be 8. B squared minus 4AC. Should be 8, not 16.
Yeah. Okay.
Yeah, then that's why the whole thing wrong. So everything need to change. Then over here, perhaps your diagram could be more accurately redrawn as something like this. The AC should be a bit slanted, not vertical. Because you may misinterpret the angle here as 90 degrees when actually it's the other angle which is 90. Compare your diagram versus my diagram. 90 degrees here. This is not 90. So your diagram is a bit misleading. Okay, I know you draw this, then you can remind yourself it's 90, but you may accidentally reinterpret this angle here as 90, which is not correct. Okay. Good. So diagram, just make it accurate. And also here you wrote down C as C lies on line L2. That is not correct. C lies on line L1. Correct or not? You wrote down L1.
Oh, yeah.
However, thankfully, even though your writing is wrong, but your thinking is clear, you copied down the correct equation. I was so scared. Wow, I see L2 already. Are you going to copy down L2? But no, you did not. You copy down the correct equation L1. Okay, so you're safe. Good. Just make sure you're consistent. I mean, this is inconsistent already. Should be L1. Okay. Yeah, then after that you find the vector AC dot product is equal to 0 because it's perpendicular, and blah 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 blah. You solve for lambda, correct, and then you sub in, you get your vector OC. Correct, well done. You found your foot. Then after that, part 2. Then part 3, you have to reinterpret the diagram. Here is a very long-winded explanation for why they are parallel. Here, let's take a look. Let's read the question first. For part 3, question 23. Not question 23, sorry, question 24, part 3. Let T be any point on the line L1. If the area of triangle ABT is constant for any value of lambda, find the value of Q. What does that mean? First thing you must know is part 2, they mentioned if Q equals to 1. If means it didn't actually happen. If I give you $100, doesn't mean I actually give you $100. I'm only considering. Nah, I'm not gonna do it. But I don't do it. Okay, so part 3, same thing here. The Q returns back to a variable. The Q is not 1. The Q is not 1 anymore. Are you clear on this?
Yeah.
That's the meaning of if. In part 3, your Q is no longer 1. It may or may not be 1. It may be 1, not 1, to be determined. We don't know yet. It reset from part 2. No link to part 2. That's the first thing you must know. Next one is, what does it mean? T be any point on L1. What does it mean? What it means is this diagram over here. This is my L1. There's my L2. T can be any point on L1 means that I have to consider this diagram. T1 or maybe T2 over here, or maybe T3 or maybe T4. T could be anywhere along this line. And then we want to look at the area of triangle ABT. Look at the area of triangle ABT. A, B, and T. You get one triangle. That's the area. A, B, consider another T. There's another triangle, there's another area. AB, take another T. There's another triangle, there's another area. I think it's quite obvious from the original diagram that the areas are not the same.
Yeah.
Right? But why aren't the question here? If you read, if the area of triangle ABT is, what's the word they use? What is the word they use? Read the question. Sorry, I cannot hear you.
Constant.
Constant, exactly. So how can you make sure that it's constant? Why? First, we need to analyze why is it not a constant. Same base. How do you find area of triangle? Base times height. Base times height. Base times height. Perpendicular height, right? So I drew for you a more dramatic version over here. These are three different triangles, possible triangles. Here's one possible triangle with a perpendicular height over here. Here's the second one, perpendicular height in the middle, pink color. Here's the third one, perpendicular height over here. Here's a fourth one, extremely dramatic one, when the T is like 1 million or something, far away. And here's the perpendicular height. Can you tell me what's the difference between all these heights? The AB is still the same length, by the way. I just copy and paste exactly. I just extended the L2. AB base is always the same. What happens to your height, perpendicular height? As I move my T away.
The same.
Let me just copy. Same, are you sure it's the same? Okay, let me just copy the diagram for you. Here's the first length. Here's the second length. Compare. Is it the same or is it longer? Let's compare the third one.
Oh, yeah, it's longer.
Let's compare the fourth one. Shorter or longer? Longer, you tell me same length. Oh,
The first is the same.
Okay, fine. That's why I drew the more dramatic one. Okay, yes. So basically, they are different when you move the T around. Why? Why is the perpendicular height different? Oh, by the way, so what our analysis tells us is that as I move T, AB, the base is fixed, but pink color perpendicular height is different. Hence area of triangle ABT must be different. Area of triangle ABT is different. But the question say what? Question area of triangle ABT is?
Constant.
Constant. How can it be? So what's the only way? Here the key is the Q is still an unknown, which means that if you look at the equation of what's that? Of line 2, L2, what is the equation? It's R equals to 0I 3J 3K plus mu times of, I have no space. Give me a moment to redraw this. Mu times of Qi plus 0J plus 2K. The key is over here. Q is still an unknown. Q02 is a direction vector which determines the angle that the line is oriented. Could be here, could be here, could be here, could be this way. So this is still a variable, which means that this fixed angle that we draw the L2 at is an assumption. We can always change the angle of L2 by changing the value of Q. Do you agree?
Yeah.
When you try to use a shovel to dig a hole through the ground, not enough strength, then you must come up with a new strategy. Instead of digging a hole through a mountain to cross the mountain, build a tunnel, you can walk around the mountain. So 另外一条路. Okay. Here's the strategy. You go by another way. If you cannot get the perpendicular height to be the same, you can force it to be the same by making this line into this line.
Oh.
Before, after. What happens? Look at your triangle ABT2. Look at your triangle ABT1. Look at our triangle ABT3. Look at our triangle ABT4. What do you notice? They all have
Yeah.
the same perpendicular height. What's the key here? L2 and L1 are?
Parallel.
Yes. Are you convinced now?
Yes.
The answer key just give one line. L1, L2 is parallel. Do you understand what it means now?
Yeah. But my
Then,
answer, I just write the one line.
Yeah, yes. No. That's just an interpretation. You don't need to prove it. Don't need to prove. You're supposed to understand this and just state it. And since it is parallel, you conclude that this guy, the direction vectors are parallel as well. L1, L2 are parallel. D1 is parallel to D2. So you can write down 101 is K times of Q02. I'm using the direction vector of L1 and L2. Is that clear?
Yeah.
This is what you need. Then after that, the Q reset, which means you need to solve for Q now. So you now have to solve it. What do? You write down the three equations. 1 equals K times Q, 0 equals K times 0, 1 equals K times 2. Can?
Can.
Okay, then after that, 0 equals K times 0. K times 0 is 0, so 0 equals to 0. Primary school kid also know this, not useful. Primary school kid knows this, but JC kid must know this is not important and I will ignore it. You choose to ignore it. Find the relevant information. Here and here is the relevant information. Specifically, K times 2 equals to 1, so K equals to half. Then you can sub in the half. So 1 equals to half times Q. 1 equals to half times Q. Solving for Q, you get 2. And that's your answer. Is that okay?
Yeah.
I think this is the most beautiful way to do it already. Parallel. Don't need to do much calculation. Okay, there's an alternate solution. You can go take a look. I don't want to go through. Okay, that is all for this one.
Okay.
Okay, I haven't had time to read your vectors part, homework 5. So yeah. Okay, for complex numbers, may I know, do you have any summary notes at all from your school?
Have, but it's like one page, like very short one.
Okay. I'll send you the notes for complex numbers later. Then I will go through that and we'll do some practice questions. I think I will only that one will take maybe 3 lessons. Okay, then that will be all for today. I will continue the homework 5 tomorrow. I mean Friday. Okay. Any questions, just let me know. There's no homework assigned for today. Maybe I'll find some complex number questions for you to try as homework.
Okay.
Like before Friday. Then you just submit to me whenever you're done. I think I'll just, maybe you don't even need to submit. I'll just go through those questions in class on Friday.
Okay.
Complex numbers. I'll send you later. Okay, that's all for today.
Okay, thank you.
Okay, thank you.
Bye-bye.
Bye-bye.